Okay, am I audible?
Yes, sir.
Okay, thank you. So this is week 7 discussion session. What was discussed in the last session? Can someone tell me that? Was there someone in the last session?
We tried programming assignment, sir.
Programming assignment of which week?
7.
Programming assignment of week 7.
Practice
Was
programming assignment.
okay, so has there been any theory session of week 7? Uh,
No,
because
I
no,
don't
sir.
think
No,
so.
sir. Okay, no.
Like as we went through the solution part, we discussed all the concepts little bit.
Okay, fine. Anyways. चलो ठीक है. Okay, anyways. So was that a TA session? I mean, the last session that you are talking about where programming assignment was discussed?
Sir, in TA session, TA did discuss the theory, and in instructor session, ma'am did practice assignment questions.
Okay, okay, then fine. Okay. Okay. Let me share my screen. Okay, so the point is, so let me just have a brief discussion, and I request whatever it comes to your mind or whatever. So those of you who have attended the last 2 sessions, just interact with me about some questions that I'm going to ask so that I get a gist of where you guys stand. Okay, so if you know the topics from earlier, if someone knows the topic, let's say you have some Java programming experience, so then please don't answer. What I want is what was discussed and where the crowd stands according to the last session. So yeah, okay. So anyway, so the questions are like this, that let us say, why are we going for exception handling? What is the need of exception handling? Can someone tell me? I mean, what is the need of? I mean, don't say that, okay, we need to handle exception, we are using try catch block. I don't want all of that. What is the main utility of a feature called exception handling in any programming language, not in Java?
So that we want, sir, the code to run without stopping.
Okay, but then that compiler also helps you with that, right? That whatever error comes, it helps you to figure out and correct. Why
So to handle those errors which are not compiler, basically which are the logical errors, which are
Okay.
not the syntax error or the compiler error or the runtime error.
Okay, nice. So which are logical error? Very good. Which will not be detected by compiler because they are basically caused by logical, let's say, anomalies from the programmer side. Nice. Other than that, any other point, specific point, let us say some other, let's say a term. I'm looking for a term particularly which is more useful in this kind of context of exception handling. A specific kind of error that might occur, which are not dependent on the programmer, which is rather dependent on fill in the blank.
So on the input side, you are asking for the input.
Exactly. Yeah. So that is very, very important. Okay. So first of all, as our previous friend already said, that first of all, it is about handling errors which are more logical towards the logical domain. So that is the programmer's fault, that he mess up in something, and that is not a compilation error because it is not a syntax error basically. So therefore syntax or type or whatever, these kind of errors. So it's not any of those. it's a logical error, and therefore compiler will not detect it, but it will cause trouble in while executing the program. And that's why those kind of errors happen at runtime. And in order to handle those problems, we need exception handling. That is first job of exception handling. So let me write it over here. So first of all, important point is to handle logical errors. Okay, and this is okay. And secondly, the second job is to handle errors caused by user inputs. Okay, the user may enter whatever he or she likes when they are operating on an application, operating on an application which is developed by the programmers, right? So they can enter anything because they are not supposed to know the internals of the program. They are just using the program for any application specific purpose. So as a programmer, you must also handle all the let's say use cases where the user may enter something which is not supported by the program or which may hinder the normal execution of the program. So you have to take care of those cases as well and write your program to cater to such situations as well, right? So it should not happen that the user enters something which is not let's say a valid input, and because of that the program crashes. So that is maybe the user's fault, but your program should be robust in that kind of situation to handle these kind of situations so that the program doesn't get crashed. And I mean, and it runs, it might run into a different path of execution, or even if it doesn't run, it will at least tell the user that you have entered a wrong input, please enter a valid input, and then it may give the user another chance to re-enter the input, right? So you have to do this kind of stuff. So that in order to achieve this, we use exception handling. So this is the second case where exception handling is used to handle errors caused by user input. So these are the two primary reasons we are going for a tool which handles program at runtime, or which handles problems which happen in the program at runtime. Okay, so at runtime, this is all runtime discussion, right? Till now, what we have discussed was all of compile time discussion. So all errors, all the troubles that were happening, they were at compile time. But now the problem is we are discussing exception handling is mainly runtime domain. All we discuss, I mean, from now on, whatever we discuss in this week, that will happen in the runtime domain. Not only in this week, what I mean is, at least in the exception handling topic, everything will be at the runtime. All errors and everything will happen at runtime. Fine. So this is the to handle errors caused by user inputs. This is basically user's fault. But both of them are happening at runtime. This is very important. Okay, fine. So these are the basically two things. Please understand these things properly, because we kind of tend to go into the syntax of all programs and different programming languages, but many of us do not have our fundamental notion of things clear. So understand these two points very important, very properly, so that these concepts are clear. Okay, so next is, after that, if that is the exception, so now we will go into the Java specific topics. So first of all, what happens is how Java basically provides you with this exception handling feature. It has a top level class which we call throwable class. Okay, class is there, a throwable class. So like in most of the, let's say, programming components are provided to you in the form of interfaces or predefined classes or predefined interfaces, and then you may implement that interface or may, let's say, extend the class in order to derive the features and write your own version of it or use it directly, whatever. So basically it is provided to you in the form of a parent class or a parent interface which you can use. So likewise here also you have a throwable class, and actually I think Yeah, anyway, so you can extend that and then you can write your own class of exception. Now, what do I mean by that? We will come to that, but let us say as of now that there is something called throwable. We will see the details of it later on. And then from throwable, we have two branchings, or basically two inherited classes, which are exceptions. And the second one is error. Now, errors are basically, we will not see the usage of error, at least in this course. Error is basically something which is happening with, more towards the system oriented problems. Maybe Stack Overflow is a kind of error. Okay, all of this is runtime discussion. Okay, so first of all, do not get confused with compile time error and exception are the two things. No, all of this is happening at runtime. Compilation error is not our topic of discussion in this week. So error, when I talk about error, error means also runtime error, but that runtime error is something different. Okay, we till now we have interchangeably used the term error and exception, runtime error, all these things. But in this week, at least in this discussion, when we say error, that means something different, and exception is something different. But due to slip of tongue, so this is where I give a disclaimer. Due to slip of tongue, since at least I am very used to, and mostly all of us are used to calling any mishap as an error. So I may say that runtime error. So please understand, whenever in this discussion I say error, I don't mean this error class. I mean normal error which is handled by exceptions. I mean runtime error. That's what I mean. Okay, normal runtime error which might happen, logical error, whatever, user input error. Because of that, there is something happening at the runtime. I mean that error. But this error which I've written on the screen, this error class is something completely different, and that's not in our discussion. Just I'm mentioning this, but it's not a part of our discussion in this week. So there is an error class. This is an error class of Java. Okay, it's not the English literal sense. It's not error. This is a Java's error class. Okay, and that error class deals with stuff like some system oriented problems, like as I said, buffer overflow, stack overflow. Okay, and there may be some other, let's say, improper program termination, and if you do multiple okay, anyway, so we are not going into those discussion, but yeah, so those are more about system oriented troubles which might come, and that is mostly handled by the Java runtime system, with sometimes with the intervention of operating system. But yeah, so we will not discuss about them. That is something different. In our domain of discussion, these two kind of erroneous situation, right? That might, when that happens, we handle that using exception. Okay, so we handle those things using exception. And again, I'm just mentioning this again, since we are quite used to calling it as error. So when I say error, don't think I'm talking about this one. Okay, if I say sometime error instead of exception, please understand I'm talking about this kind of runtime error only. Okay, so now we have this exception class, and this exception class has some features, and later on we will see that in Java you can define your own exception. You can have your own exception class. What are the situation in which we might need such a facility? We will go to that and see with an example. But you can have two kind of situation in Java. First of all, there are already some predefined exception in Java, okay, which we mainly call runtime exception. So these are classes. Okay, runtime exception is a class. Exception. All of these are classes which you can see on the screen. So runtime in green color. So runtime exception is also a class. And other than that, so I'm not writing the name of the class over here. So I will write in red. So this is a unchecked exception. And this is not a specific class. That's why I'm changing the color. Runtime exception is a class, but this is not a specific class. It is a type of exception. Like runtime exception is unchecked exception. So the type of a runtime exception is called unchecked exception. Okay, and this type is called checked exception. Okay, so now what are these two types? So when I say checked exception, but I also am saying that it is inherited using exception class. So what I mean is checked exception is a type. It's not a class. You can define any user defined exception. I just said that earlier, right? You can have your own exception class created. So when you create your own exception class, you will give it a name, right? Class something XYZ. Extends exception, right? In order to implement your own exception class, you will write some class XYZ extends exception, right? Oh yeah. So then you will do whatever you need to do, close the class. So we will discuss what I mean, whatever you need to do. What are these lines of code? We will discuss later on. But let us say you create your own exception class by like this. So this will be basically XYZ, right? So the corresponding name in this situation will be your XYZ. So since that is a user-defined situation, I'm not writing any specific name over here. Just writing checked exception. So checked exceptions are mostly user-defined exceptions, and runtime and unchecked exceptions are something different. And runtime exception class is one such example of unchecked exception. So this is kind of the structure of the exception hierarchy provided to you by Java. Now, what are these things that we will discuss? So what are checked and unchecked exception? So checked exception, strictly speaking, checked exception means these exceptions are monitored by the compiler. Unchecked exception means which are not monitored by compiler. Now, the first doubt which should come to your mind is, just now I said that exception deals with runtime situations. So why compiler is again coming into the picture? So you see that there are two cases of runtime exception we have discussed, right? First is to handle logical errors, and the second one is to handle situation where the user has entered something which I do not desire to supply to the program, right? Some wrong user input. Two situations are there which might lead into some, let's say, wrong situation at the runtime. So first of all, let us have a discussion on both of these situations. First of all, we have these logical errors. See, the second case, which is due to user input, if you have a workaround, so let me just frame it in this manner, that if you want to have a workaround in your program, right? If you want to have a workaround, that this is a trick that I will apply in the program. You have been given a trick, some magic trick have been given to you, and you want to apply that, and that will help you to bypass or let's say bypass a specific kind of situation. Now if I tell you that you have this kind of trick and you can bypass any one of these two situations, first of all is to handle logical errors, and the second one is to handle wrong user input. So you see that it is better to use that trick to handle the user input situation, to bypass. When I'm saying bypass and correction are two different things. Correction means you are basically correcting where the trouble is occurring. Bypass means you are not correcting the situation, you are just making a workaround of that situation, or let's say workaround from that situation. So if I tell you that you have a bypass tool, then among these two situations, it is better to use it on the second one. Why? Because if there is a logical error in the program, that means in the inherent working of the program, in the natural, let's say, execution path of the program, there is some problem which should be properly corrected, right? Because otherwise the logic of the program is not properly reflected in that program, right? Whatever the logic was, whatever we were trying to develop, that is not properly reflected in the program. So that is a grave error, and that should be properly corrected. That should not be allowed. There should not be any workaround of that. It should be corrected, full stop, right? There should not be any trouble with that. But if I'm talking about wrong user input, so that is something which you cannot guarantee will never occur. There is nothing to correct in this situation. So if the user enters something wrong, you always have to make your program in such a way so that you have a workaround of that situation. You cannot do anything to stop the user from entering wrong things. Only thing that you can do is you can protect your program from proceeding with the wrong user input, right? So you see that workaround only suffices in the second situation where user enters something wrong. But if it is the first situation where you are writing something wrong as a programmer, there should not be any workaround of that. It should be corrected, right? So I hope this idea is clear, what I want to at least share. So there should not be any workaround in the first situation, but in the second situation, you have to have a workaround. So because of this, we are dividing into two specific types of exception handling in Java, which is checked exception and unchecked exception. So unchecked exceptions are these kind of exceptions, right? Which are happening because of some logical error done by the user, done by the programmer. So that's why they are called unchecked, because the compiler does not check the occurrence of these errors. I mean exceptions. Now, what do I mean by the compiler does not check the occurrence of this exception? We will see that in the program. It will make more sense after, let's say, a few minutes later. But what I mean is, just as of now, keep this thing in mind that compiler will not check this. That's why we call them unchecked exception. But checked exception are such exception. Basically, as I already told you, checked exceptions are user-defined exception. These are the exception where the compiler will check the validity of this exception. I know, again, it is getting a little bit confusing. What do I mean by compiler checks, and again, what do I mean by validity? Just bear with me. When we see the program, it will make more sense. But just have this little concept in your mind that a checked exception, as the name suggests, are being monitored or at least being checked by the compiler. Unchecked exceptions are not monitored by the compiler. And the reason for that is unchecked exception mostly deals with the first scenario where the logical error has happened, which is programmer's fault. But in the checked exception, they mostly deal with to handle the wrong user input or some specific user, let's say some specific that application specific features that I want to implement in the program, which might be with respect to the user, which might be something else, some extra feature that I want in the program, stuff like that, right? To handle that kind of situation, it's not something logically wrong. It's more about feature or more about providing a safety net kind of situation, which is basically a feature again. So therefore, those kind of things are being checked by the compiler. Okay, because I don't need that to be. So unchecked exception, why are they not checked by the compiler? Because if it is checked by the compiler, well, when I say when an exception is checked, what do I mean by that? The compiler is checking it and telling you that, okay, have you done this or not? But unchecked exception, the compiler will not tell you anything. Okay, why? Because the compiler is not telling you anything, so that unchecked exception, along with that problem, whatever problem you have written, compiler will not tell you about it, and you will go into the runtime. You will see that the program is crashing due to that, because you have done a logical error, and you will come back to your code and you will correct it. So that is the reason compiler will not check it. Compiler wants you to make the mistake, go to the runtime, basically run the program and go to the runtime, crash your program, come back and correct your code. So that's why we are calling them unchecked, because the compiler is not checking them, and the reason for not checking them is we want it to be wrong. I mean, we want you to crash, or basically the compiler wants you to crash and come back and correct your code. So that's why we call it unchecked exception. Now, again, what do I mean by compiler does not check? That we will see in the code. Right? So this is the philosophy of unchecked exception and checked exception. So just briefing it one more time, checked exceptions are those kind of exception which are checked by the compiler and mostly deals with the second kind of situation of exception handling. Unchecked exceptions are not checked by the compiler, and therefore the compiler will not tell you about anything regarding these kind of exception. And you will write, if you write something wrong, you will go to the runtime, you will crash your code, come back and correct it. Right? So the exception will happen, and you are expected to correct your code. So this deals with the first kind of situation, which is to handle logical errors. Okay. So this is kind of the philosophy of exception handling in Java. Okay. So now we will go to the code and see some coding part. And I am not going into the try catch, what are those things, because in Python you guys have already done exception handling. I hope you guys know what is try, and here we use the catch clause, right? So catch clause is basically written to handle the, so that is the exception handler part. Try is like normal Python's try, same concept. And here we also have this finally. There is a finally clause in Java, which basically means that whether some exception happen in the try clause or does not happen in the try clause, whether even if the exception happens in try clause, even if one of the catch clauses, catch that exception, or it may not catch that exception, whatever may be the situation, the finally block will be executed for sure. Okay, so if you have a try block along with a catch block, along with that you also have a finally block. No matter what happens in the try catch block, whether exception occurs, whether it doesn't occur, whether it occurs and caught by the catch block, whether it occurs but couldn't be caught by the catch block, whatever happened, in all kind of situation, the finally block will be executed for sure. Okay, so that's what finally block deals with. You can have a try block and a finally block. You can have a try block with a catch block, but you cannot have a try block all alone. You must put one of the catch or finally block along with the try block. That is another important point. Another important point is that if you define a variable in the try block, you cannot access that in the catch block. So this might happen sometimes, that in order to write your program, you define a variable in the catch block. In the try block itself. When you have started the try block, inside the try block you write a variable, and then maybe you are trying to access that variable in the catch block, in the subsequent catch block. So that is not done. So you cannot access anything declared for the first time in try block inside any of the catch block or finally block. Why? Because in Java, basically the structure of exception handling looks something like this, that we have this try block, and let's say that we have a catch block. Okay. Maybe you have another catch block over here, and then you have a finally block. So it looks something like this. So the problem is, if you define a variable, let's say int x over here, and you are trying to access this x variable over here or any place, you cannot do that because the context changes. So let us see if an exception occurs at this line, the second line exception happened. So what does exception mean? That means an error has occurred, right? Error means, again, I'm just telling, error means normal runtime error, not that Java class wala error. Okay, so normally till now, whatever we have used, that meaning of error. So if some runtime error happens, right, which is basically, that means an exception has happened. Sorry. So what basically happens in the system whenever there is a exception or error, whatever you want to call it, that has occurred, what happens? So basically you will see on the output screen or in the terminal, print will come that this particular line has experienced error because of this reason, little bit of information about that, and then the program halts. Right? That's what happens. So here also, inside the try block also, whenever there is an exception occurring, same thing will happen. But then this is called, this week is dealing with exception handling. So basically I need to provide a way to go out of that situation, right? I cannot stop the program. So how try catch block handles it internally is, the context is switched. Now what do I mean by context is switched? So whenever you are executing any program, not only Java program, any program, and not only programming languages program also, any music you are playing, you are, let's say, opening your browser, whatever, any software that is that you are running on your computer, right? So that will be represented as a process in the RAM. So in your primary memory, which is your RAM, it will be represented as a process running. Okay. So what is process and all those discussions are not in the course, so we will not go into those details. But let us say, just understand that we call it as a process, and the process term is quite self-explanatory, that it is a process of things that is running, which basically reflects the working or execution of your VLC media player or your Chrome browser or whatever, anything that you are doing, any application that you have run, is the image of that is a process in your RAM, right? And a Java program also, whenever you are executing that means a new process is getting launched. Whenever I am pressing the run button, that means a new process is getting launched, and that process is executing. So inside that process, right, we will have these stack frames, right? Whenever we call a function or anything happens, so all the function calls that we do, So they are stored as a activation record in the processes stack, as we have already discussed that. So this stack, like this, in the initial week we discussed about this, right? Activation record and all. So those that stack, right? That stack belongs to this process. So now you understand which process I'm talking about. So this process is also called context, right? So this whole thing which is running corresponding to a program, this is also called context. So when I say context switching, now context switching is also discussed in a different way in operating system discussion. So that is basically discussed when multiple processes are running and operating system is switching the execution between different processes. So let us say you have VLC media player running along with a browser, along with, let's say, something else. So different processes are there, and the operating system will switch from one process to another in order to execute all the processes together, right? So whenever you are writing a mail on your browser and playing a music video on VLC media player, obviously you can have, you can hear to the music by putting on your headphone, as well as at the same time simultaneously you can write your email, right? The music doesn't stop when you write your email. So this is what context switching works in this fashion. So how is that possible? Because processor is dealing with one stuff at a time. So processor will first work along with the VLC media player some part, and then after doing the work, it will go to the browser, the execution corresponding to the browser, and it will do that part. Until that time, whatever work it has already finished with respect to VLC media player, that is what you are hearing, right? So it works like that. So that is a discussion of context switching. But in this discussion, context switching is something different. So this is this is also called context switching, but in a different meaning. So I just mentioned that for the sake of completeness of the discussion, that is operating systems context switching. But here what we are discussing is something little bit different. This is Java's internal. So once you have a process, you are running the process which is corresponding to the Java's program which you are running, right? And inside that, we have a context switching that is happening inside that process only. Okay, we are calling it context because here the context means the normal execution of the program. So whenever the program is executing, the normal execution, the normal, let's say, line of execution, if that is hindered by an exception at the runtime, then if you have used try-catch block, then Java understands it. Okay, since exception handling mechanism is used using try-catch blocks, I will allow the program to take another path where I have got hindrance, right? I will, from that point of hindrance, I will take another path and go into the catch block and see what is being written inside the catch block. So then suddenly you understand there is
Sir,
tell.
This context switching is somewhat different because it is still sequential execution, like unlike operating system, which is time-based asynchronous switching. This is somewhat sequential execution.
Correct. Yeah, exactly.
Okay.
That's why I differentiated between these two things earlier, because you shouldn't get confused. If some of you are aware of what context switching means, then operating system context switching, if some of you are knowing about that, then you will feel very much contradicted about what we are going to discuss. And that's why I specifically said the operating system discussion. I spoke that so as to keep this thing in the record that is something completely different, but we call both of these things context switching because here the context doesn't mean the process, rather the sequential execution path which is done, the normal line of execution, the first line of execution in Java program, right? So that's what I'm calling the context. Here the context does not mean the whole process. So yeah, exactly. Okay. That's right. Okay. Yeah. So for those who do not know operating system context, forget all that I said just now. Just whatever I'm going to discuss now, that is enough for your understanding. So yeah, so anyway, so when there is a normal, obviously any Java program, when it is executing, line by line the execution will happen, line 1, line 2, line 3, the process will, the program will be executed like this, right? One by one, all the lines will be executed. So that is what I'm calling a sequential, or let's say the line of execution, or the sequential direction of execution. So sequentially it is proceeding. And let us say it is proceeding like this sequentially, all the lines over here are done. And at some point over here, it is getting a exception. That is basically a runtime error has happened. So it is getting an exception, it is getting blocked. So if you have not used any exception handling mechanism, which is basically your try catch, if you have not used that in your program, then the program will terminate. Over here, you will see on the terminal, the program has terminated with a message to you that this thing has happened. But if that is not the case, if you have used try catch block, then there will be a separate track, okay, from here, where the program will see, okay, since try catch is used in the program, I will allow another path to be taken and I will see what is there inside the catch block. So this is basically done to see what is there in the catch block, this path of execution. So a new path of execution starts. So I discussed this in order to make you understand. So this is a completely new path of execution and it is primarily done so as to check what is written inside the catch block. Is it handling the exception which occurred or not? If it is handling the exception gracefully, then maybe I will allow the program to proceed. And so that depends on what is written inside the catch block. But if it is not handling the exception properly, then again I will terminate the program anyways, because the exception has happened and it must be caught and it must be handled. Okay. So what do we mean by handling the exception? That also will come. So that basically deals with what we will write in these blanks. Okay, but basically, so this is the reason catch blocks are, let's say, we see what is there in the catch block. Now you see that if I have done something inside the try block, so that line of execution has completely stopped. So when I take another line of execution, so inside that execution, I don't know what is defined inside the try block. So the context has changed. So therefore, if you have defined something inside the try block, that will not be recognized in the catch block or in the finally block as well. Only the things which you have written outside the try block in the main part of the program, not main part, what I mean is outside the try block. So let us say you have written over here int y. So this y you can access. Y you can access, but x you cannot. Okay. So because whenever try catch block, whenever you are starting a try block, program already, how the internal program works is whenever you are starting a try block now, whenever you are writing this try block, your program will basically already create a temporary context. Because why? Because if you have written a try block, you suspect that there is something that some exception might occur within this area. So how the Java program works is it will automatically create a separate, let's say, temporary box, you can say a sandbox kind of thing, which you can call context. So inside that, it will execute what is written. And if nothing happens, then it is okay. The program will continue along the normal line of execution. But if a trouble happens, if an exception happens within that sandbox, then whatever was there within that sandbox will be rejected. So everything will be flushed and the program flow will take another execution path and that will see what is there in the catch block. So since whatever was there is flushed, so therefore the existence of this X is not recorded. Right? Because of this, you cannot access anything which is written in the try block inside the catch block. I think in one of the examination, we had one question about everything was correct. All the features were correct. Just that one variable was there inside try block. And on the basis of that, we are handling that in the catch block. Right? You will not find any logical error, any other syntax error happening other than this thing. So most of the student, more than 90% of the student wrote that there is no compile, there is no exception in this question. Right? So please keep this thing in mind. Anything defined in the try block is already put inside a separate context or a separate sandbox, whatever you want to call it. If an exception occurs, that whole sandbox is being flushed out, and therefore any variable that you have discussed, that you have declared inside the try block is not accessible within catch or finally block, because the context is getting switched, because the line of execution is getting changed completely. Okay, so that is one important point. Another
Sir,
thing
in this case, is it a compiler error?
error means exactly. The compiler will only tell you that you cannot access X. Okay.
It is like, sir, a global and local variable type thing.
Exactly. Compiler will tell you. You don't have to go to runtime. Okay. Fine. So another thing is, let us take one small example, and I want you to say what is the output of this code. So So let us say okay, I'm writing just print, assume that it is system.out or what that whole thing. Okay. And let us say this is inside some method called fun. Oh, print is already there. Okay, anyways. Fine. So, what is the output of this code?
So it is going to first print A,
A,
then
A, then 8.
A then
8.
8, right? Okay. So please keep this thing in mind. So this is the correct answer, by the way. So whatever. So you see that the return statement is there both in try block as well as in finally block. So you might think that I might print A and then I might return 3, and then finally is also having return, but at least my try block should finish. What I told is finally block is executed for sure, but finally block execution will happen at the end, right? And after try block is finished, or after, let's say, catch block is finished, it will happen for sure, but it will happen at the end, right? Finally happens at the end. That is correct. That definition is correct, and that's how it works. But here it is a little bit tricky situation. Here what happens is, obviously try block first print A will happen. Then after that return 3 statement will also will be executed. But what happens is return 3 means what? So you have to see these things in a little bit, you have to think about it a little bit. If you just understand that, okay, finally blocks, try block, both have return statement, the final is return will be the final, I mean, ultimately return to the function. If you want to remember it in this fashion, you are fine. I mean, I don't have any complaint. But if you want to understand what is happening and why this is happening, because according to the definition of finally block, it will execute for sure, but it will only execute after the try or catch blocks execution is completely done. Or in case an exception occurs and the try block is bypassed and the catch block is basically, we are coming into one of the catch block. Even if one of the catch blocks handles it or none of the catch blocks handles it, but at least investigating through all the catch block has been done. And finally, after that, the finally block will execute. So what I mean to say is, the point is finally will be executed at the end. So end is highlighted. But in this situation, you see, so that means what? Is the return 3 of try block not executed? According to the output, it is not executed. So that's what I am saying. So if you want to question this point, so how it is happening is A is printed, that is fine. After that, return 3 is executed, that is also fine. But you see, return statement basically pops the context, right? When you have a function in the activation record, so suppose this is the activation record. This is the activation record corresponding to fun method, right? So whenever the return 3 statement is done, I mean is executed, that means this activation record will be popped out. That means the return. So return always pops out that activation record. So it will delete this activation record from the program stack. So what is the definition of finally? Finally will execute always at the end. So whenever I see the program is saying that the return statement is encountered inside the try block. So before popping the stack, it will go to the finally block. So you see, the return is actually executed. This return tree is executed, but the result is not returned yet. Compiler knows that the return is there and it has gone through the return tree line. It has seen that return tree line. It has gone through the return tree line. But since return, the work of return is to pop the activation record, it will not pop the activation record at this point. It will just stop and it will go to final. So the return here does two things. Okay, you have to understand that the return statement has two parts. First of all, the compiler goes through this line. This is happening. Okay, this is happening. But the activation record is not popped. Okay, so this is a big part. If finally wouldn't have been there, then both of these things would have happened, simultaneously. Like in normal return statement, till now, wherever you have used return, both of these things would have happened, it did happen automatically or simultaneously. Okay, but here it will not happen simultaneously. These two parts will be separate. So the first part will happen. So that will actually guarantee that you have executed the try block completely, and then only you are going to finally block. But the difference is that the AR is not popped. So then you go to the finally block and you see that again there is a return statement. Right? Again there is a return statement. If I would have written here print B, so then after A, B would also have been printed. But anyway, so I have after that we have returned it. So now the finally 3 was there, that was to be returned, and after that it is implemented in the form of a stack. Whatever you are returning, since it is implemented in the form of a stack, so 8 will come on top. Because here later on I am coming to finally, and later on I am looking at 8. So 8 will be kept on top, and then after the finally is executed, then we know that anyway return was trying to pop the stack. So I have to now do that task because finally's execution is done. So I can now pop it. So the second part of the job is done after that. So now I will just pop the stack frame and try to see what is there on top. So you see on top 8 is there. So then you return the value 8 and pop the stack. So this is what's happening. Don't get confused that the return 3 is not executed. Executed in the sense compiler will go through it, but compiler will not return the value because it has to go to the, because in order to do that it has to pop the activation record. So it will not pop it, it will go to finally, see what is there in the finally, come back and then complete the popping part of the activation record. But since finally also has a return statement, that return will be kept on top, and since stack work in the form of last in first out, so therefore your 8 was the last value, therefore that will be the value returned. Okay, so this is a little bit in-depth discussion of what's happening. Yeah. But even if you remember in this format that, yeah. Go ahead. Go ahead.
Sir, is it allowed to have a try block without a catch block?
As long as you have a finally, you can do that. Okay, so try block with catch block or with finally block. Okay, simple try is not allowed.
So, sir, in this case, if we did not have the return in finally, then he would have printed return 3.
Correct.
The
Correct.
3 thing.
Correct.
Okay.
So, sir, at what point exactly is AR popped?
After AR is popped when I come back from here to here again. So you see that 8 was kept on top of the stack, and then I popped it and returned 8. But 3 is also there, but it is not getting reflected because last in first out behavior of stacks. Right? Okay, sir. Anyway, so maybe that much depth was not required, but I'm kind of a systems guy, so you have to bear a little bit. Sometimes you have to discuss. I tend to go into this.
Yes, sir. Yeah, it was interesting. Same here.
Okay, thank you.
Sir, one question. You
Yeah.
mentioned with a try, same thing happens with a catch also? Like if it was a catch and finally
Correct,
try
correct, correct. The catch and finally is something which is not allowed. You at least, so catch cannot be there without a try.
No, no, I
If you
get
have,
it, sir. If it was a try, catch and
uh,
finally, but if it was a
correct.
return,
Same thing, same thing. Same thing. If you have a try, catch, and finally, and what, no matter whatever you write in the catch block, let's say in the catch block you write return 1000. So first try is 3. So only thing that would have happened is, let us say, let us take the one example. Return 3, inside over here you have another catch block, and over here you write return 1000. Okay, but then actually what happens is, if there is no exception that is happening in the try block, none of the catch block will be checked for anything. Only finally will be checked. So it doesn't make any difference. And if there is an exception at any point within the try block, so this return 3 will not be seen. I mean, so basically then also this 3 will not come in the stack. Only 8 will be there and 8 will be returned. But again, to answer your question, even if try, catch, and finally all 3 things are together, no matter what happens, whatever is there in the finally, that will be the value, because that will be executed at last. And since stack works in a last in first out kind of fashion, therefore again 8 will be at the top and it will be returned. Okay.
so well, like the 8 from the return from the this finally will be there, and either from the try or from the catch. It can't be both, because if there's an exception, the try will automatically hand over the control to the catch. Then.
Exactly.
Okay, got you.
Okay, so now we have discussed this kind of context switching. So please understand this. Now we are not doing Python. Okay, so because Python was more about introduction to your programming, how to implement multiple stuffs. In Java, we are looking a little bit into the systems, that how programming languages work, and having a little bit idea of all these internals, little bit closer to the systems approach. And I think there is also a C course which is optional. You guys, if someone is interested later on, they can take, I think, later on. So if you do that course, then you will actually go into the proper, more into the systems perspective. So what I want to say is, please understand these topics, okay? Because it might not be related to, or maybe in your OPP, you will not be facing a lot of help. You will not get a lot of help by understanding this kind of concept. But if you understand these kind of concepts, right, it will help you in the long run. So how try-catch is different from other features provided to you by any programming language. So this is not only in Java, Python also handles in this fashion. So whenever any programming language which helps you with exception handling, see, exception handling is a very special thing, because exception is nothing but an error, right? A runtime error. Now, whenever an error happens, the program stops its execution. So how is it that only you have written catch and whatever, in other language it might be something else, and you have written that thing, and the program which was terminating in the earlier situation, when you have not written any of the exception handling, let's say, keywords, the program was getting terminated. But now once you have written this, the program is not getting terminated. It is allowing you another path to be taken. That is okay. Somehow it is allowing. But how is it allowing? Because according to the system's point of view, an exception or an error, whatever you want to call it, it happens, terminate. The context is popped out. So if the context is popped out, if the activation record is, sorry, not AR, in this case, the whole process's context. So if that is completely removed, then how can you again come back into the program? How is it internally implemented, right? So that is happening because whenever you write this try block, there is an internal temporary sandbox getting created, or context, whatever you want to call it, that is getting created. And if there is nothing happening within it, if no error has occurred, so it will be continued in the normal line of execution. But if that is not the case, if something wrong happens, if an error happens, so that whole sandbox is flushed out and another line of execution is followed, which is done in order to see what is there in the catch block. So have this idea in your mind, and this is common in all programming languages. Okay. Okay. So now let us go into the program. I wanted to discuss these few points which are not quite discussed in the lecture, and mostly not will be discussed in any live session as well. Now we will see the programming parts. Okay, so as I already told you that we will deal with two kind of problems in this exception handling situation. First is your problem due to logical errors, which is programmer's fault, and the second is problems due to wrong user input, which is the user's fault. But then also we have to somehow make a workaround in that kind of situation. So let us take this example. So this is something that I wrote in order to remember it. I wanted to discuss this. So see, in the slides, sir has used some coding examples which are a little bit difficult for many of you to understand. May not be difficult. I'm not talking about difficulty with respect to the understanding of how it happens. Rather, the difficulty is about implementing them. So if you invest some time and try to complete the code which are partly snippet wise given in the slides, you will feel difficulty, because there are a lot of concepts which are not, we have not yet covered those things. And many of them we will not cover in the course as well, because these are mostly application oriented concepts. So let's say connecting an SQL database, stuff like that. So yeah, so the thing is, so those examples, sir has taken those examples in the slide because those are the real situation where you will encounter exceptions. Okay, in the live session, we kind of try to give you a flavor of the concept by making different examples. But in real life situation, when you are coding something, you will actually encounter those kind of trouble in the specific situations which sir has discussed. But again, in order to discuss those situations, we do not have the tools because the prerequisites are not done. We cannot discuss SQL connectivity now. But in order, if we had discussed that, then we could have also discussed the exception which might occur while working with SQL databases. So therefore, yeah, so you have to clear with that part. So yeah, in this coding example which I'm going to discuss now, I will discuss with runtime exceptions. Okay, so what I mean is, here I told you that runtime exceptions are basically unchecked exception, and the idea is compiler will not check this exception because compiler wants you to basically fall down. It wants you to go to the runtime and fall down and come back and correct your code, right? But in our discussion, what I'm going to discuss now, I will use runtime exception only to discuss all the concepts of exception handling. Okay, but practically speaking, runtime exception should not be done anything. If a runtime exception occurs, you come back and correct your code. No exception handling with runtime exception. Okay, this try catch block, nothing. Don't do anything with runtime exception. If there is an error, do not do try catch block when runtime exceptions are occurring. What are runtime exceptions? We will see such example. That's why I'm going into the code. But before that, I'm just making a disclaimer. Whenever just 1 second. Whenever runtime exceptions are occurring, you do not write try catch block. This is from your programming perspective, programming philosophy perspective. Later on, when you are coding, don't do this. Runtime exception occurring means come back, correct your code. Do not use try catch block. Only in case of checked exception, there you go and use try catch block and do stuff. And that will be cleared with example in subsequent discussion. But since, as I already told you, in order to discuss the concepts of exception handling, how these multiple keywords and all these features that Java provides you in terms of exception handling, in order to discuss those features, I will use runtime exception only. So that means I will use try catch block with runtime exception example. I will use throws keyword, throw keyword, all these things, fancy things with runtime exception as example. Because I do not have the means to discuss it with real example, like sir has at least given the snippets in the code, right? So, but again, that's why I'm saying it again and again. Please don't have this philosophy in your mind that runtime exception is happening, write a try catch block. No, please no. Runtime exception, you correct the code. Checked exception, there you use try catch block. Okay. So have this disclaimer in your mind. This is just for understanding purpose. We will use runtime exception for discussing the keywords provided to you by Java for exception handling. Okay. Now, yeah, go ahead. That's what I wanted to say.
Yeah, so sir, I was saying that these runtime exception also includes the input, right? Input
uh,
coming
uh,
from.
It might happen sometimes due to input,
Hmm.
because see, runtime exceptions are primarily stuff like you are dividing something by zero. You are accessing the array out of bound. You are trying to convert a particular array type into another object. I mean, one array defined as one object type into another object type. So class cast exception. So these are stuff that the programmer has to take care of. You are
Yes.
accessing array out of bound means you have written the loop in a wrong manner. That's why the loop is going one more iteration inside the array.
Yes.
Right? So those kind of things, it should be
Yeah.
properly corrected.
So those runtime exception we need to handle. We need to think of those situations where things can go bad, and then we have to give correct try catch there.
Correct the code. So let us say if your array is getting out of bound, I mean, in the situation where user has not given any input, okay, you are writing code and your code is somehow going out of bound. It's simple. So let us take an example. You are sorting an array. So in order to sort an array, you have to take a loop and go through the array and do stuff, right? So somehow it is going out of bound. Will you write a try catch block for that? No. Why? Because you have done some problem in the basic function of the program. So basically, you correct that problem. You don't write a try catch block because there is nothing about trying and catching. You have done some logical error. So correct that logical error. Okay. That is the idea. So, but if user input is coming, right, and depending upon that user input, something wrong is happening. So then you use try catch block that, okay, if something wrong is entered by the user, then you do this. So that if and then clause is making you write try catch block. But if you are sorting a sequence of number and your program is showing you an error, maybe array index out of bound error. So that means while writing a loop for sorting the array, you have initialized the loop wrongly, or you have written the loop termination condition wrongly. And because of that, it is going one extra iteration, or it is going to access the array in a wrong, let's say, address. It is trying to access the array. And because of that, trouble is coming or error is coming. So that is not something to, let's say, handle using exception handling, because it's not an exceptional situation. It is something, a normal error that you have done. So you correct there. So then only you will have this.
Yes, sir.
Array
Yes, sir.
index.
I was also saying that this user input or any kind of input that we are getting from a request of server or anything like that.
Okay.
So these things can produce some value which might be like not easy to handle with direct if else conditionals.
Correct.
We may need try catches for that.
Exactly. Okay. So what I want to lay stress is on this factor that only use try catch block when it is absolutely necessary. And what is the thing that makes it absolutely necessary? Situation which might happen at runtime depending upon any value entered by the user or any feature that you want to provide to the user. Now that what I mean by this second thing, that feature that you want to provide to the user, that will be clear in the next example that I take. But yeah, so that is the point. But if your program is not taking any user input, or it is not doing something which is dynamic, which might happen at runtime, right? Your normal program execution, you are writing a simple program. If some error is coming into that, then exception handling is not the way to go. If a runtime error is happening in your program, correct your program. But if at runtime some error is happening because of the some dynamic thing that is not predestined or pre-decided, like user input is not pre-decided, so then in stuff like that or in situation like that, you use try catch block. That is the philosophy of exception handling. Okay, so now let us take this example and see how things are done in Java's exception handling. So we have this sides of triangle array list. No, this is array only. So we have this array, and so then we have this scanner class object that we have decided to take that we have declared to take inputs. Let me make this a little bit And then we have a choice variable, which will be basically using for this do while loop. So as you can see, we have this do while loop. So this do while loop will basically loop through multiple choices entered by the user. So therefore, I have this choice variable, which will be taking the decision, for the do while loop's condition check. Okay, so as you can understand, it is initialized to n, so the user can enter yes or no whether he wants to continue or not. So that's what the choice variable will do. Okay, so then what I'm doing is I'm starting the try block. So enter the stride length. So what I'm trying to do in this code is, so we have this array, right? So I will ask the user to enter a value, which is basically called the stride. So stride means, let's say, a length of numbers, or let's say a span. You can say a span of number, which basically means, let's say the user enters stride to be 2, right? 2. If the stride length entered by the user is 2, what I will do is I will take the first number, which is 1, and the second number, because the user has entered stride length to be 2. So the second number from 1, which is what? 4 and 9. So the 9 is the second number from 1. So I will take 1 and 9 and I will sum them up. Okay. Then again, I will take 9 and the second number from 9, which is 9 and 25, and I will sum them up. Okay. And then again 25 and the second number from 25, which is 25 and 49, and again sum them up. Likewise, I will go to the end of the array. If the user had entered stride length to be 3, then I would have taken 1 and the third number from 1, which is 1 and 16. Then again 16 and 49, 49 and 100. Okay, so that's what stride is basically doing. And I will do the summation of all these pairs of number and store them in another array. As you can understand, there will be a array which we will need in order to store these multiple pairs of summation. So that array is basically what we call the hypotenuse array. So this is basically your Pythagoras theorem, hypotenuse square. So in hypotenuse square array, this is what we have named it to be, hypotenuse square array. Okay, so we will sum and keep them in the hypotenuse square array. That is what Pythagoras theorem is, basically a hypotenuse square is equal to summation of side square. So here I have already written the array sides of triangle square. That's why the name is sides of triangle SQ, which is basically sides of triangle square. So these are the squared values of sides of triangle, and we will do the summation, pairwise summation of any two numbers within this array to get the hypotenuse length squared. And therefore we are storing that value in the hypotenuse square array over here. Okay, fine. So what will be the length of this hypotenuse squared array? That's the question. So as you can understand, the length of the hypotenuse squared is basically the number of pairs that we will have while basically for each stride, whatever be the number of pairs that we will do the summation for, that will be the length of hypotenuse squared, because so many hypotenuse we will need. So if the stride is, let's say, 3, so I will have 1 and 16 first pair, 16 and 49 second pair, 49 and 100 third pair. So for stride value 3, I have 3 pairs of number to be summed up. So I will need 3 hypotenuse. I mean, the hypotenuse squared array will be 3 in size, because 3 hypotenuse will be generated. So likewise, you can understand, if I do the sides of triangle, that array's length divided by stride, so that will give me the number of pairs that I will get. Basically the number of pairs that I will get to find the different hypotenuses, right? So therefore, I am storing that value sides of triangle divided by stride into iterations. So that will also mean that so many number of iterations are there, because so many number of hypotenuses will be generated. So these iterations, and then I'm just storing that in this new array called hypotenuse squared array. Okay, and creating a hypotenuse squared array whose length will be the size of iterations. I hope till now this is okay. And after that, what we are doing? Normal while loop. We are just while iteration is greater than 0. For all the numbers, I will do the summation in order to fill up this hypotenuse squared array. So we have now generated the hypotenuse squared, but we have not entered the value. So I told you, so summation of these two numbers. So as you can understand, it is always I and I plus stride, right? So that's what I am doing. I plus stride element, I will sum up and store them in the hypotenuse squared array. Okay, and as you can understand, in the next iteration, I am going I plus stride. I hope you're getting this, I equal to I plus stride, because first 1 and 9 is done. Suppose if the stride length is 2, 1 and 9 is done. Second, in the second iteration of the while loop, 9 will become the first element, right? In the first pair, 1 and 9, 9 is the second element, but in the second iteration of the while loop, 9 will become the first element. So that means what? The iteration variable, which is I, so that must be incremented by stride amount every iteration, right? So that's why I equal to I plus stride is written in order to update the iteration variable. So yeah, so then iterations minus minus. So how many times I am basically going through the while loop? So normal while loop to traverse the array. And then we are printing the hypotenuse squared array. And then I am asking the user that whether you want to continue. If he enters yes, we'll continue. Otherwise, I will stop the program. Simple program. Just I have an array. I am asking the user to enter a stride value. I am generating whatever stride he enters. I will generate so many pairs of number and sum them up, sum each pair and store them in the hypotenuse array and then print the hypotenuse array. Simple thing. Now, where can we have runtime exception in this situation? So let us divide the situation. So as I already told, there are two possible scenarios that might happen. First is user input situation, or let's say the second one was user input situation. The first one was the programmer's logical error, right? Two kind of situation might happen. And mostly we use try-catch block for the second situation, which is user input situation. For logical errors, we will try to correct the code itself. We will not use try-catch block. That was the motivation. But I also told you, for discussing concepts in this, I mean, standing where we stand in our current understanding of Java, we cannot deal with multiple advanced concepts. So I will discuss all the concept of exception handling, I mean, try-catch block and all these things with runtime exception only, because I do not have the means. So therefore, I will discuss with runtime exception only. But please understand, we do all this try-catch block with checked exception. Okay, runtime exception, try to correct your code. Again, I am mentioning that. But now let us proceed. So what situation?
Sir, is it okay if I just ask a couple of questions about the code?
Okay, yeah. Sure.
If you scroll up, we first begin with a kind of an array, right? Which is, if you scroll up a bit, please, sir.
Acha.
Okay. I think it's somewhere along, yeah, line number 11, yeah.
Okay.
So we have this integer array, and then we are in line number 12, we are reading something. What is it that we are reading? Where is this S going, sir?
We are not reading at line 12. We are just creating a scanner object.
Scanner object, and then we have a string choice, and this is going to be what, like
this one. At the do while loop, when we are ending, this choice is equal to next line. So, do you want to continue? Yes or no? The user, suppose I am writing a program where the user has multiple, he can iterate multiple times. So basically, he can enter stride value 2, and the hypotenuse array will be created using stride value 2. Then again,
can you just explain that part one more time also? Like we have array of these are what sides, and then like how are we doing the, I mean, hypotenuse, sir? I'm not getting the connection.
Simple thing. Okay, so we have this hypotenuse, we have this sides of triangle array. Okay, this is sides of triangle, let's say SOT array, sides of triangle array, which was already predefined at the top of the program, and it has some number of elements. I am asking the user to give a stride value. So stride. So this I am asking user. So user input, user will give one stride. So user inputs. So user input will be a stride value, right? And then with this stride value, I will create the hypotenuse array. Because obviously this stride will determine how many pairs of number I will get. As I told you, if the stride value is 2, I will take this number and the second number, which is this number, second from this one, right? So first number from will be 1, this second number.
This will be the 0th element and the second element as the two sides of a triangle.
Yeah, exactly.
And we are going to use the 0th element and the second element, and then from that we're going to calculate, as per Pythagoras theorem, the hypotenuse. And
First
this,
hypotenuse.
this is going to be the first element that goes into the hypotenuse array.
Correct.
Right.
Correct.
Then the third element, which is second 2 and 4. These
Correct.
two lengths are going to then go into the. We are going to calculate the hypotenuse based on these two sides and then put it into as the second element in the hypotenuse array. This is how it's going to go.
Exactly. Exactly.
And then we have the flexibility. The user has the flexibility to change the strides. Like instead of like every alternate, we can go by like one, not one and alternate. Like you can go for like 1 and then 2 and 3.
Whatever. So we will tell. So first, if the user enters a stride value, we will calculate the hypotenuse array just like what you said. But then once the hypotenuse array is created, I will print the hypotenuse array. Okay. After that, after it is getting created, after printing the hypotenuse array, so print the hypotenuse array. Okay, hypotenuse array, and then I will ask the user again, do you want to continue? So here we will ask user, do you want to repeat? Okay, do you want to repeat what you just did? Okay, so if the user says that yes, I want to repeat, then I will come back to this point, that enter another new stride value. Okay, so the user now, in the second turn, user may enter stride value to be 5. So once the user enter a new stride value, obviously the hypotenuse array will change. So I will do all these steps once again, and then so this is the thing that I am doing. So we need the do while loop to implement this, right? Because we will loop again back to the first point, and the choice variable is basically storing this yes no choice. So that's why it was initially initialized to no variable, because if the user does not enter anything, then it will be terminated. That was it said. And you see the do while loop condition was actually, yeah. So you see that while loop, you see this is the end of the program in the do while loop. Choice dot equals ignore case y. So the equals ignore case is basically the equals function which will ignore the case whether it is capital or small y. So either way it will consider the y to be continuance of the program or it will terminate the program. Anyways. So
understood, sir. Thank you.
So now let us, so this is a small program. I hope we are cleared with what we are doing. But now, what are the troubles that might happen? Program is this much. But first of all, user may enter something which is not a valid stride. Let us say the user enters a negative number, a -6. Obviously, that's not a valid stride length. Even if the user enters 0, that is also not a valid stride length. From 1, it is allowed. 1 means pairwise. Every alternate, not alternate, every let's say, what do I call?
Adjacent.
Adjacent. Thank you. Yeah, adjacent. So every adjacent number will be summed up. So 1 and greater than 1 is okay, but less than 1 is not a valid stride. So the user input is there. So first of all, user must enter something which is greater than or equal to 1. That is one thing. But other than user input, is there something that we have done wrong? So let us say the user enters a value 2. Okay, so stride length 2 is a valid number because your program should work properly. But if I enter 2, what will happen? What are the pairs of number that will be considered? 1 and 9, first pair. 9 and 25, second pair. 25 and 49, third pair. 49 and 81, fourth pair. After that, 81 and nothing else, right? I do not have anything to go with 81. So basically till 81 I will have how many pairs? 1 and 9 first, 9 and 25 second, 25, 49 third, 49, 81 fourth. So I have 4 pairs of number when the stride is 2. 4 pairs of number. So therefore the hypotenuse array should be 4 length array, and in them I must have the summation of these 4 pairs of number. Okay, so the hypotenuse should be 4 length. Let us see what we have done over here. Iterations is basically the size of the hypotenuse array, right? Over here you can see. So sides of triangle dot length divided by stride. What is the sides of triangle? Length 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 numbers. 10 divided by 2 is what? Because stride length is 2. So 10 divided by 2 is 5. But how many pairs did we have? 4. Right? So the iteration will be 5. Hypotenuse squared array will be of 5 length array. But how many pairs of number are we getting? 4 pairs of number. So in the 5th iteration of the while loop, because iteration will be 5, right? So in the 5th iteration of the while loop, I plus stride will be what? 81 plus 2. I mean, not 81 plus 2, the index of 81 plus 2. Isn't it? So in that case,
It's out of range.
correct. So we are going array index out of bound exception will happen. So you see that this is not a trouble which is happening because of any user input. This is something because you have messed up in your logic of writing the program. This kind of situation is what we call runtime exception. And this is practically, it will generate a runtime exception when the user enters 2 as a value. Okay. And that exception is basically one of the runtime exception. And let me come back to that hierarchy. Yeah. Okay. That runtime exception is one of the so this is called array index out of bound exception. So this is a class. Array index out of bound exception is this array index out of bound is a class. Just like runtime exception is a class, so this is a subclass of runtime exception, which means array index out of bound is a runtime exception because it is extending runtime exception class. Okay. So array index out of bound exception will be generated at runtime, and you will see that the program halts and it shows you line number itna pe is array index out of bound exception is happening. Okay. So this is a runtime exception. So that's why I said these are unchecked exception and the compiler will not warn you about anything. So what do I mean by compiler will not warn you about anything? That is not yet discussed. We will discuss that a little later, right? Because logical error, so anyway compiler will not see. But what do I mean by unchecked and checked part? That is something different. We will come to that a little later. So this is by the
Sir,
way.
even in this case, the compiler cannot know from beforehand what is going to be the error.
No. Correct. It will not know because it is a logical error, right? But then you might say that this is logical error, compiler will not know. Then what is the situation in which I am saying compiler will know? So that's what I am trying to say. This unchecked and checked meaning I have not yet discussed. I will come to that a little later because this is specific to a feature that we will see a little later. Okay, so just do not have this idea of unchecked and checked as of now. We will come to that a little bit later. As of now, just understand that array index out of bound exception which is occurring, and you can see that this is happening purely due to the fault of the programmer, coding fault, logical fault, and therefore it is one of the runtime exception because runtime exceptions are basically user's fault exception. Programmer's fault exception, and because of that you must correct this kind of error. Do not write try-catch block, you must correct it. But in my example, I have written it in a try-catch block because of obvious reason which I already said. Because I do not have the tools to discuss real unchecked exception as of now. So you can see that how to handle this. So if I want to give the example of try-catch block in order to handle this kind of situation, how to handle this situation. So we have written over here to see this catch block, runtime exception E, right? And then now once you come into the catch block, oh, by the way, another important point I did not discuss, but what I feel is you guys must have heard about it in previous session because one of the session was theory session anyways. So if I have multiple catch blocks, so let's say catch over here, then again, let's say something is written, then again another catch over here, right? Something is written. So likewise, I have multiple catches over here. So in this kind of situation, how we basically do is we will write the class name, exception class name in this area, right? All these catch block, whichever kind of exception I'm trying to catch within that particular catch block. So whatever I write in these parameters, right, I have to take care that these are written in a form of more specific class to later on towards the more general side. So what I mean is, from top to bottom as I go, the catch arguments should be specific to generic, as we okay. Now, why is it so? Because if you write a more generic, by the way, what is specific and generic? Specific means subclass. And because all of them, all exception will be at the top, it is exception class, right? At the top, I showed the hierarchy. Exception class is sitting at the top. All exception will be exception classes, subclasses. So therefore, as you can understand, in the previous example as well, I just showed that array index out of bound is a type of runtime exception. Now, runtime exception is a type of exception. So as you can see, this will always be one of the child class, sub parent class situation will happen for all the exceptions. So we have to just write the catch block in the fashion that on the top, whichever catch block is there, that should be the one which has the maximum specific or basically the last level subclass in the hierarchy, so that it can catch that particular subclass exception. Okay, why? Because if you write the generic exception at the top, then other catch blocks which are later in the series or later in the ladder, they will not be at all checked for. Only the first one will accept all the exception that is occurring, and it will deal with all the exception. Now, you might say, then what is the trouble? I can write one catch block and it will handle all the things. So here is the trouble is that, and I will show you with the example, that you don't want that kind of thing, right? In a program, there can be thousands of different exceptions that might occur. You may run out of bound. You may do something, let's say some illegal class you want to typecast into another type which you have not planned earlier, but you have done something wrong. So you might have thousands of different kind of problem happening in the program. If you have only one catch block which is catching all types of exception, then inside the catch block body you do not know the specific exception which it has caught. Right? While writing the code, you do not know at runtime which exception will occur in which execution of the program. Right? Sometimes the particular exception occurred, later time the user entered something else, depending upon that another exception occurred. So different exception might occur in the program. In a complex program, different exception might occur at runtime, depending upon user input, depending upon thousands of other factors. Now, if you write a generic catch block, then you do not have the means to write a handler for specific scenarios, right? You do not know that catch block how to handle a specific problem. So therefore, you want multiple catch blocks which will handle different situation of exception. And in order to catch different situations of exception, catch those error exception that are occurring, you use the catch block in the sequence that the top one will catch the most specific exception. Then the second one will catch a little bit less specific exception, and the last one will catch all generic kind of exception. So at the last catch block over here somewhere, when you have the last catch block, there you can write exception, and exception E. So this exception object will, that means when you are writing the handler in this line, right, whenever you will write the handler within this space, you know that I don't know any other scenario where exception might occur. I have used all the corner cases that came to my mind, at least as a programmer. I have written their specific handler in order to solve each of the specific situation. But if other than all of these exceptions that came to my mind while writing the program, if some exception occurs which is not yet coming to my mind, but it might happen at runtime, or in order to hold those kind of exception, I am writing this catch block. So that is the idea of this exception E, which will hold all the exceptions, because as a programmer you don't have, you have written the specific handlers for different kind of exceptions which came to your mind that might occur in the program. But if there is something left out which is not there in your idea, in order to hold those kind of exception, you have written this catch block. So this is the reason we follow this technique that we write the smallest one at the top and the widest one at the, or the narrowest exception type at the top and the widest exception type at the bottom, so that we can understand which catch block is catching what kind of exception, and I can write the handler specific to that kind of solution or specific to solve that kind of exception handling. Okay. So
Sir, one
Sir,
quick question.
we cannot catch two types of exceptions
yeah, you
simultaneously,
can
right?
catch in the, no, two kind of exception will not occur. Na? Any exception which occurs in the first situation, that will make the program terminate and go to the catch block. So two kind of
Okay,
exception
okay.
will never
Understood,
occur.
sir. Understood. Okay,
Yeah,
okay.
someone else was also asking something. Go ahead.
Yeah, sir, it's not necessary that as we go down the catch ladder, the ones at the top are the subclasses of the ones below who are the superclasses. They could be unrelated also, not part of the same class hierarchy. If
I
I'm
got it. I got it. But the point is, if you see the exception hierarchy, na, because obviously catch block is only handled, I mean, is written to handle exception. So whatever you write as an argument in the catch block, that is an exception type object. That is for sure. Now, if that is there, you see the hierarchy of exception is linear, right? And most of it is in this fashion. Only there is one branching, which is in this case, exception for checked exception. So, if in your program you have a situation where checked exception might occur, unchecked exception also can occur. So, all of these are unchecked exception, right? Runtime exceptions and all its subclasses are unchecked exception. So, in a program, you have both unchecked and checked exception which might occur if that is the situation. So, at the end of the day, you will anyway write exception at the bottom. This exception E, which is basically connecting both of these two branches together, right? And in between this exception E, I mean, in between this catch block, if you want to handle a specific runtime exception or a specific unchecked checked exception, then both of these can be may not be in the linear inheritance hierarchical fashion. If you want to handle both of them, but within a particular branching, so within your unchecked exception, let us say within this branching, right? Within this branch, there will be multiple again like this, right? So maybe another one, then maybe another one. Like array index out of point is one, you are extending it from runtime. Again, you might have something else that is extending from array index. Again, you have another one that is extending from. So within this branching, you must follow the hierarchy in the catch block. But if you are talking about this branch and this branch, then you may not follow the hierarchy. Among these two things, you may basically mix up, right? But within the branching, you must follow.
okay, sir.
Fine. So let us come back to the code. But practically speaking, let me just give a little bit point over here, one more point. Practically, again speaking, coming to the same thing, I'm repeating 1000 times because this is very, very important for conceptual understanding of how we write code. Runtime exception, you will never write try catch block. So you will basically see what is the runtime exception which is occurring at the runtime, because it will show you the name, array index out of bound, whatever, arithmetic exception, whatever is the type of runtime exception, it will be printed in the console, right? You see the name of that exception so that you get a hint of where the error is occurring and why the error is occurring. You come back to the code and you correct the code. So that's the philosophy of handling, I mean, basically what you have to do in case of runtime exceptions. So therefore, while you are really writing a program and not explaining people about how Java offers exception handling, when you are really writing an application, you will basically you will not write catch block for these branches of exception. You will basically correct your code. Only in this branch where you will need try catch blocks. So in that case, it will anyway be the same case. It will be one length. I mean, like this, the hierarchy will be a linear hierarchy, right? So ultimately, your catch blocks will satisfy the narrower to wider, let's say, inheritance chain which we discussed.
Understood, sir. Thank you.
So okay, so now we see this catch block, which is this catch block runtime exception we have written, right? and we are checking whether the runtime exception also has multiple types, right? So we are checking array if the instance E is instance of array index out of bound exception. I am specifically checking this. Why? Because inside the if block, I want to handle the array index out of bound exception in that specific manner, right? So therefore, I am printing array index issue because I do not know. Runtime exceptions are not only array index out of bound exception. There are thousands of runtime exceptions that are there. So what I mean is array index out of bound exception is one subclass of runtime exception. And inside runtime exception, I have multiple types of runtime exception subclasses, right? So therefore, I do not know which one has occurred, but there I'm just checking that if E is instance of array index out of bound, then I am printing accordingly to the user that the array indexing issue has occurred, and that is the information that I'm giving to the user. Okay, and then I'm print stack trace. So this print stack trace is a method of this exception object, runtime exception object E, or in any exception object, you can use this print stack trace method, which prints the stack of where the exception has occurred. So let's say line number 32 exception has occurred. Then that 32's value is being propagated. Let's say the value which is there at 32 is coming from line number 12. So the stack trace will give you the trace of all the, let's say, contexts from where the current line has reached the exception. Okay, so it will give it, it helps you in order to debug the program. That's what. So as you can see, the print this throwable and it's backtraced to standard error stream. This method prints a stack trace for this throwable object on the error output stream. That is the value of the print system.error. But if you did not understand anything, no need. This print stack trace will print the, we will see in the example as well. It will print the lines of code where the exception has come, and let us say if multiple lines of code are involved, then it will print all the lines of code. So when I say multiple lines of code, what I mean, so suppose you have written a function, function1, another function, function2, another function, function3. So 3 functions are there, and inside the main method you are calling fun1. Inside fun1 you are calling fun2, inside fun2 you are calling fun3. Okay, now a value is being, and let us say fun1, fun2, fun3, all these 3 are parameterized function, and all of them are basically, whenever I am calling them, I am putting a parameter inside them. So you see that the parameter from main is being passed into fun1 while calling fun1 method. Some task is done inside fun1, and then I am calling fun2 with one of the parameter, maybe the same parameter, maybe different parameter. Okay, fun2, and then likewise it is going to fun3 as well. So an exception occurred at fun3. Okay, so let us say that fun3's line number is 2, line number 12. So the stack trace will print line number 12 fun3 exception. Then it will also print line number where the fun3 is called inside fun2. Then it will also print fun1 line number where fun2 is called, and then the main line number where your basically fun1 is called. So as you see in this example as well, my class.main, my class.crunch, my class.mash. So mash is basically the point where the error has occurred, the exception has occurred. Mash is getting called from crunch, crunch is getting called from main. So that's why the whole stack trace, I mean all the functions which are involved in, to the point where the exception has occurred will be printed. So this helps you in debugging purpose. So that's what this print stack trace does. And it is a very common method in order when exception handling is done to print the stack trace so that we understand where the error has propagated from.
Sir,
So,
if we throw an error, or if an error occurred that we don't catch, then the default output system standard error will also give something similar. I have like noticed this thing.
Exactly. If you do not handle anything using catch block, or if you write the catch block in such a fashion that all the exceptions are not caught. So as you can see in my example, I have written the last catch block as exception E, and it guarantees that it accepts, it catches all the exception, because exception E is the superclass, ultimate superclass. So if I delete this exception E, so then it might so happen that some exception which I have not caught yet, that might happen in the program, and it will not be caught by any of the catch block which I have already mentioned, because it is not an arithmetic exception, it is not a runtime exception, some specific other type of exception has occurred, right? So in that situation, no catch block will hold it, right? So in that kind of situation, the program will come to the main method and it will see that main method is also not basically correcting it. So the program will terminate and Java will print the stack trace of the code and it will show you that in this line the error has occurred. And if that line is there inside another function, then all the functions which are there till that point, all the functions from starting from main to that function, all the intermediate function will be printed and the corresponding line where that function is getting called, where the next function is getting called will be printed. Like in normal Java execution where we have not done any exception handling, the same thing happens. It basically prints the stack trace. So you are correct.
Okay, sir.
Yeah.
Okay, sir.
Okay.
Sir,
So
one
then,
question.
yeah.
Sir, when you mention like sprint stack trace, it gives you the entire where which function has been called. So does it always give from the place it was initiated till the final?
Exactly. Exactly.
What I'm trying to say is that you said fun1 calls fun2 and then fun2 calls fun3. Now, what if I have a stack trace in fun2? Will it also observe or catch that it was called in fun1 or main? Are you getting my question, sir?
I'm getting the question exactly. See, the stack trace is a property of the exception object. So it's not a property of, let's say, the function. So you cannot, even if you print stack trace inside the body of fun2, right? So that till that point, stack is the common stack of the program, right? It is not, let's say, it is not particular to any function. It is a property of the program. It is a, let's say, a part of the program. So the stack will contain all the function from main, and that is the sequence. Right? In wherever, from whichever scope you want to call it, from fun2, fun3, main, wherever you are calling the stack trace, it will print the stack trace itself because that stack is only one stack, the program stack. So that will anyway be one stack, and therefore from wherever you want to print it, it will print that stack on it. So yeah, it will always print from main to the point where the error has occurred.
Understood. Thank you.
Okay. By the way, even without
Sir.
printing the tell.
This stack trace, this is not part of the logging thing, sir, right?
No.
This is different from the.
This is just the program stack. So if you in IDE this Visual Code, if you just let us say not only stack trace. Let us say I want to do it over here. You see that if I debug the code, I hope you guys know what debugging is. Python, you have done debugging, right?
Yes,
guys-
sir, but not through this debugger. We mostly do it by either by manual breakpoints or printing statements.
Printing statement is, I understand that is the initial way we do it, but breakpoints you have done, right?
Somewhat. I don't think so. Everyone have done
Okay.
that.
No, actually, no. We haven't done it.
Okay, so what is breakpoint is basically if let us say I have a program. What breakpoints is, this is not in Java, this is normal programming concept. If I have so many lines of, let's say, program, right? And 1, 2, 3, 4, whatever, right? And let us say I want from here till this line, I am sure there is no problem. Okay, so then these are fine. But let us say I don't know, but somewhere between these lines of code, there might be some issue. So the error or the, let's say, it might be an error. It might be the output is not coming as I'm wishing it to come due to some logical wrong thing that I have done, or maybe some logic. Basically, I have done something logically wrong, and because of that, the output is not coming correctly, right? So that is not an error itself, because the compiler will not tell you anything because there is no error, but the output is not matching, right? So in that kind of situation, if you want to closely look at what is happening, what is the value of each variable, which we call dry running, right? The manual dry running, as our friend already said, that by using print statement, which you have done debugging, right? So you print the value of a variable in between different parts of the code. After multiple lines of code, you write a print this variable in order to check what is the value of that variable at that point, right? So rather than doing that, that is a very tedious and let's say, for lack of better words, a novice kind of way to debug a code. But what we basically do is, when you want to really debug some code, you can use these debuggers which multiple IDEs will provide you. So what you do over there is, where you are sure that there is no trouble with the code at within these lines of code, you may, I mean, you don't do anything, but where you have a idea that, okay, maybe in these 4 lines of code, or maybe these whatever X number lines of code, there might be some trouble that can happen. And then again, let us say there are again multiple lines, and these 2 lines are fine. Then again, between these 2 lines, again, I might have some issue. Have some issues, right? And these are again fine, right? So these are again okay. So you have these multiple, let's say, chunks of code where you are not comfortable about it, and you want to inspect the variables in these lines of code, or the logic that you have used in these lines of code. So if you have encountered such a situation, how you can troubleshoot, or how you can find out where you are making the mistake is, you use breakpoints, right? So this is the process of debugging a code, because you are deleting, or you are basically correcting the bug which is there. That's why we call it debugging. And we basically use breakpoints to help you do the debugging. So what are breakpoints? So you basically, in Visual Code IDE, you come to the line of code over here. How to set breakpoint is, you see that this is the code, right? This is the line numbers, and we have a little region over here in the left hand side. As you can see, when I'm moving the cursor, a red dot is coming on the left side. Now if I go to line number 13, let's say, and I make a click over here, so our permanent red dot is set. So you can see that I have 2 red dots set already. So these 2 are breakpoints. So this is the way we set breakpoints in, at least in this IDE. In different IDEs, you can set the breakpoints in different manner. So what will these breakpoints will do is, so let us say here I set the first breakpoint, okay, and then the second breakpoint I set over, let us say here also. Then again third breakpoint over here, fourth breakpoint over here, and then again we have some lines of code which I'm sure that they are also fine. So these are also, let us say, okay. So now I have set the breakpoints over here. So then what I do is, I will have few buttons, which is play, pause button, move forward button, move back button, like this kind of buttons will be provided to you. Right? And when you play the code, the program will execute very fast till this line, but here it will stop. This line it will stop, and here it will, on the left hand panel, you will be able to see the variable values, what is the stack trace till this point, everything related to the program you will be able to see on the left hand side of your screen, or in some ID on the right hand side of the screen. It will show you the current position of different variable, current value stored in different variables. All those things will be shown automatically. So you don't have to write a print statement for all the variables that you want to inspect at this particular line. So you break the code at this point. This dot will tell the programmer, tell the compiler to stop execution, and you can check the current status of the code and the variables involved on the screen. And then you can, let's say, press this button, which is proceed by one step. So it will go from this line to this line, the next line. Then again proceed by one step, this line to this line. And accordingly, every line, when it is executed, the changes in the variable will be reflected and shown on the left panel.
Sir, I think this thing, not in the VS Code, but our Python tutor is also very similar. Python tutor, that website, provide a very similar functionality.
This is a common feature, I told you. I just discussed this because I asked that whether you guys have formally learned about debugging or not in Python. right?
Yes,
Many
sir.
of you might have used it. Many of you are still using print statement. So don't use print statement. My motive is I don't want anyone who is present in this session to use print statement to debug their code from now on in any language you are coding. Okay. So debugger is a feature provided in any IDE, in any language it will be there. Okay. So please use that. Yeah, so step by step you can move forward, and you let us say in this line also you come. After this line, since that breakpoint is now over, then again if you press this one button again, so then it will directly skip all the lines from here and come to the next breakpoint. So all the lines of code which are here. Now in this example I have only one, so let us say there is another one. So these two lines will not be checked at all, and I will come to the next breakpoint, and then again I will go one by one. Okay, so these lines will be executed in a batch. It will not stop the code. It will just like here it got executed in a batch. Here also it will get executed in a batch. So therefore, basically you set the fault points where you assume there might be some trouble. You set those points and you execute the program. So all the other part will be executed in a batch, and where you have set the breakpoint, the program will stop and ask you to go one by one. So you press the button and it will proceed one by one step, and all the value of the variable and the stack trace will be printed on the left side so that you can inspect what's happening. So that's what we call debugging. This process is called debugging. And this feature of breaking the program at specific lines so that you can inspect the values of different variables involved is what we call breakpoints. Okay.
Yes,
So,
sir.
so that's what I'm doing over here. So let us say I set a breakpoint. Why I discuss this breakpoint is the stack trace which we discussed, that is also visible in breakpoint. When we, my idea was I would have just said that when you set a breakpoint, you can also see the stack trace, right? This is the same stack trace. So that is the idea that I wanted to say. But yeah, anyways, so this is the call stack. As you can see, whenever we see the breakpoints, the call stack that you can see, that is essentially the same call stack that will be printed in case we write the print stack trace. So as you see in this case, if I only thread main is there because we have not written any function, but just suppose, first of all, let me stop this. Just give me 1 second of time. Oh. So as you can see, I have written this code. If I then, let's say, execute this code using breakpoint, so suppose in the first line itself, I want the code to be broken so that I can see the stack, right? So you see code 11 dot main. So main is, the main method is currently in the stack. So you can see this is called stack, right? So this thread main. So this is the main thread. Other than that, there are also some threads. So these are not part of our discussion. So always see what is there in the main thread, right? So this is the call stack corresponding to the main thread. So just assume this is your stack. This thread main is basically your stack. So main thread. Let us go one step over one. Oh, sorry, I think it was step into was the right. Just a second. So let us see now. I will go one step. You see what is happening on the stack? See on the left hand side in the stack. See main,
Yes, sir.
and then I have fun, right? And then if I press again, see the print stream dot println is coming because print stream is a class, println is a function. Since I'm using the print thing, so that is written because that particular class, like that is also a function, right? So that function will also come into the call stack because I'm using the print statement. So therefore, it is showing that. Now, if I
Sir,
step,
it just jumped. It just jumped to that thing.
correct. Now, if I just step over from here, or even if I step into, you will see that it is going to the third one, that fun2. See, right? So main fun2. Then again, if I go step into, right? Again, the print stream is coming because of the print statement. Sorry. Step out. Yeah. So I think that was the last, right? Fun2. So after this, if I step again, so but if I move forward again, so that means the fun2 is get terminated. Fun2 has already executed. So I will pop the record corresponding to fun2 from the stack. So if I just move again one step ahead, so fun2 will be popped up, right? So as you can see, the fun2 got removed. After that, fun will be removed because I am returning back to main. Fun is getting removed, and then if I step one more ahead, the program will be terminated because the main will also be removed from the call stack. Thread.exit, because that's the last function call. Because yeah, this is basically a program termination call, which happens at the end. The program. So there are some things that will happen, thread container and all, because that is the end basically. I will step out. So as you can see, that's the end of the program. So you can understand that this is what the call stack is, and this call stack, which is there coming on the left hand side, that will be printed when you write the print call stack. By the way,
Thank you, sir. Thank
yeah.
you, sir, for making us aware of that. Thing.
Yeah. So one important, not important, one funny thing that you can do is just when you have this constructors, right? Multiple constructors in a inheritance hierarchy. You have 4 classes, and all of these classes are in a one line of inheritance, right? Subclass like that. And you declare objects of the, let's say, the ekdam chota wala class, so ekdam which is there in the ultimate subclass. You make an object of that using the constructor call. Normal object, you make it using a constructor call, right? So you can see the constructor chaining happening in a beautiful manner. That we know that whenever we call the constructor of the child class, automatically the constructor of superclasses are called, right? So you will be able to see, just do this, add a breakpoint before you call the constructor, before you declare the object, and then see the call stack. It will be a beautiful thing to see, that you will be able to see that you are only creating the object of the child class, but whenever you are executing that line of code, the call stack will have one by one, it will go to all the constructors till the top, actually till the object class, and from object class it will pop back again and come to the main method. So that can be seen beautifully. The constructor chaining you can see beautifully in this call stack. Anyways, coming back to our.
So in that case, where do we set the breakpoint? In the main method where we create the object?
Just before you create the object.
Okay.
Okay. So coming to this code. So we have discussed this print stack trace was there, what it is doing, and then we are using the system.exit. So because to I'm basically terminating the program. So these are the things which is you can do. Whatever you want to do, you can do inside the catch block. That is basically handling.
Sir,
Yeah.
so this system.exit is exiting with the status code. Are these the status code of Linux processes?
Yeah. So these are operating system, not Linux processor. as
Yes,
such.
sir. OS processes. Yeah.
Yeah, exactly.
So 0, if we are exiting with 0, then it will exit normally. But what if we exit with 1? That is,
Yeah, so these are various indication to the, let's say at first the Java runtime system, and then from JRS to the operating system, that what are these exit code supposed to do. So basically this is how you handle different situations. So if there is a stack overflow, then the program will exit with a separate exit code. It will tell the JVM to basically, let's say, delete whatever is there inside the stack and reinitiate so that a new program can be started, and some background bookkeeping task that you have to do. So different exit code tells the JVM and the operating system to do some background task in different situations. Right? And,
yes, sir. So if like if we just keep it to 0 and 1, 0 for like normal exit and 1 is just some error occurred.
Huh.
So will the output be affected by this status
No.
code? Like
No, not in that sense. Mostly no, but the output will not be affected. What you can see on the screen and stuff like that. But the internal work that behind the scene is happening, that JVM will do, that will be affected.
Yes, sir. That will be affected. Okay. So the standard output screen is not affected at all.
No, not in
Okay.
that sense. No.
Okay, sir.
But if you really mess up something, that I am also not able to give an example as of now, but if you do something very wrong, most of the time it will be automatically detected by JVM and it will not be allowed. But somehow if you manage to mess up something, then maybe in the next iteration, next execution, you might get something wrong. But that doesn't happen normally, because JVM is very secured and it will see if there is something wrong, it will take care of that automatically.
Yeah, we need chain of processes to create that kind of thing.
So that actually, one thing that is coming to my mind is, it's kind of extra discussion. So there is, in C language, there is something called fork. Actually, similar thing is also in Java is also there. Most languages it is also there. So fork is something you do, multiple processes are created. So again, we have not discussed process in detail because that is an OS topic. But anyways, since you mentioned just, so basically from one program you can launch another program. Right? So in Python also, I think it is not. I think it is there.
Yes, sub-processes module is there, Python.
Exactly. The sub-processes modules are there. So you can launch the sub-process from the first program. So basically you are launching a new program from the current Python program, right?
Yes.
So likewise, let us say you write a loop, which is an infinite loop, and make multiple sub-process inside that infinite loop. So that
is an error. That is a very common standard error in Python.
Right? Yeah, so that is what we call fork bomb, or basically in this case, I don't know what is the term used, but in normal systems point of view, we call it fork bomb, because the process of creating multiple sub-processes is called forking. So fork bomb we call it. Now, if you apply a fork bomb, so the system error code that because the program will terminate after some point, it will hang up, and error code will be generated, and that will be sent automatically within the compiler, and they will know that, okay, this is what I have to do in order to restore the system to the previous state. So some bookkeeping task has to be done, some refreshing, some deleting, buffer management task, all these things has to be done. So the error code or exit code basically decides the task that you have to do after you exit the program, depending upon what is the current situation of the internal resources that the program has, created, or that the program has resulted into. Right? So yeah, that is the point. So those things will be affected, but your normal output will not affect that much.
So one more question, like this course covers concurrent programming.
We will come to that in week 10, I think. Yeah.
Week 10, okay.
And that
What
is
kind of concurrent?
concurrent
Like
means threading. Threading. You will have
okay,
multiple
threading based.
threads.
Okay. Okay, sir.
So there are multiple things in terms of concurrency, but we will see mainly the threading part, because this is a Java object-oriented programming discussion. So we will not go into the details of concurrency or hyper execution or stuff like that. But basically, we will discuss what is concurrency and how you can have multiple threads in your program so that all those threads can parallelly do some task. That's what we will
Yes, sir.
discuss.
Okay, sir.
Now, if you guys say that we want another session in details about how things are working behind the scene, so we can do that as an extra session after your exam. We can have a discussion session. And I would
Yes,
be very
sir.
happy to do that because that is my research domain. So I am.
Yes, sir. That would be really
Yes,
fun.
sir.
Yeah. So-
There is going to be only 3 of us there.
Yeah. So, anyways, coming back to the main discussion. So here we have this runtime exception and array index out of bound we have discussed. Other than that, there can be some other types of runtime exception as well. So you can write it in the else, or basically this outside this if is else part, right? So this is the else part. Basically, you can say there I have written this again print stack trace. So what I mean to say is you can write anything. It's not that I've written this stack trace because this is the norm. There is nothing like that. What I mean to highlight over here is we write this catch block in a specific fashion so that we can filter out different kind of exception and write handlers with respect to each of those specific type exception, a specific handler, so that that particular handler handles situation depending upon that particular exception in a very specific way. So that helps you to give the user a proper information that, okay, this is the problem that has occurred. Specifically, this is the problem has occurred, and you give your input accordingly. Or if I have done something wrong, I will take care of that accordingly. So that is why we do this specific behavior of filtering out different kind of exception using multiple catch blocks. And if required inside the catch block, again, we filter out more specific type using this if statement and instance of operator. Okay. So that again, we have done this runtime exception. But other than that, what was the second scenario? The first scenario was that even if the user has entered 2 value, but the array length was getting out of bound because we have not written something correctly. Now, in this example, I used try catch block to, catch that exception and show the user that the array index has gone out of bound. But is it a good termination from your opinion? Because the user has entered 2 value. User knows that I have to enter value which is 1 or greater than 1. So user will say, okay, I have entered value 2. Still you are telling me, still the program is telling me what? Array indexing issue. That's what the program will tell the user. And then it is printing the stack trace and then it will exit. Now, what will the user feel? That array, I gave you correct input, you give me the output now, you are telling me array indexing issue. What is this? So this is the reason I said that whenever these runtime exceptions are occurring, you have to go and correct the code because these are your logical burden. You should not put it to the user that something has happened and I am not able to run the code. Okay, but yeah, so in this case I have used try catch in order to discuss the concept. But can someone tell me where logical error is done from my side? Where I have done something wrong because of which the array is going out of bound? What I can make change in the code? What change can I make in the code which will allow me to delete this catch block completely?
So the iteration, the initialization of iteration, sir.
Okay, what is that? What I have to do?
We have to somehow like limit that thing to the length of.
So can we use a floor?
Floor, but if I use floor, what will happen? The sides is 10 and stride is 2. 10 by 2 will be 5 anyways. Floor function also 5. Everything will be 5. Ceiling, floor, whatever you give, it will be 5.
So stride plus 1 would it work?
Plus 1?
No, for say that will, you can't say plus 1. Plus 1 so definitely not. I think minus 1 also may not be valid for every case.
Why?
No, what if it's like it gets exactly divisible by the number of arrays? We don't, like, we get everything.
You said a little bit earlier floor. right? Now just add the two ideas together. So if it is not
Either or, if it's divisible by, okay.
right, if it is not divisible, anyway, since the iteration variable is int, it will take the smaller value, right? Not only the integral part, not the fractional part. So
Right,
basically it will take the floor. So if you use -1 over here, that basically solves the problem. In fact, this is a very common initialization statement in case of any programming, not in Java or anything, the normal initialization in Python everywhere. So when you are basically initializing a variable which is dependent on array length, you always subtract the array length by 1, divide by any number corresponding to your code. Why? Because the array length will be whatever XYZ X value, but the number of element. So let's say if I have an array length of 6, what will be the index of the array? 0, 1, 2, 3, 4, 5. Till
Yes.
5 we will, right? So iteration variable is directly used in order to set the indexing value over here. So later on, not over here, over here also as well. Yeah, right? Because I will go till iteration minus, I'm doing all this stuff is happening. So therefore, always keep this thing in mind whenever you are using array and dividing the array length by something. This kind of statement, whenever you are writing in any programming language, most of the time it will be array length -1 divided by that whatever number you are dividing. Right? Okay, so if I do this thing, only this add this -1, then I can delete this whole runtime exception catch block. Right? Because this thing will never occur. Array index will never go out of bound. Then I can remove all of this. But just since we wanted to discuss how catch block works, therefore I did not do it like this. But ideally you should come back and delete this -1 because this is a runtime exception. Okay, another thing. Now we will come to the second part, which is the area where you should write a try catch block, right? So that is basically user input, wrong input kind of situation. So what can happen? So where the user has entered any negative value or 0 or stuff like that, the stride length to be something like that. So then what will happen? So let us say the user has entered 0, right? So if the user has entered 0, what will happen?
Division error will be thrown.
Exactly. So this stride will be divided by 0, which is infinity. So okay, so this will be 0. So the divided by 0 becomes, meaningless in terms of computer. So therefore, divided by 0 exception, but there is nothing called divided by 0 exception in Java. What we call it as an arithmetic exception, because arithmetic exception is divided by 0 exception is not, there is nothing called divided by exception 0. Whenever divided by 0 happens in the code, arithmetic exception is the name that is used. So arithmetic exception is thrown. So you can see that I have mentioned arithmetic exception over here in the catch block. So this catch block will catch the exception corresponding to divided by 0 situation. And so what is this e.get message? So get message is another function. So I have used these different functions which is provided to you by the exception object, like just to have a display of all the features that are provided by this exception class objects. Get message, print stack trace, these are all these kind of things. So get message basically prints a message regarding the current type of exception which you have encountered. So you see the definition is telling you the detailed message string of this throwable instance. Right? So it will just tell you why this exception has occurred. So then system.out.println that I have now again printed something that please enter non-zero stride. So this is a specific reply that I am giving. How can I give this specific reply that it is non-zero, that you have entered 0 value? Because I know that arithmetic exception will only occur when 0 by divided by 0 might have happened. And therefore, I am sure that I am writing this message inside this catch block, because this catch block will definitely hold arithmetic exception only. Right? So I hope you are getting the point why I told that we have to always write from specific to wider, or from narrower to wider exceptions in the catch ladder, in order to basically figure out which exception is being caught in the current catch block, so that we can write handler corresponding to that particular specific type of exception. The handlers
So
will
it's
be different.
debugging process kind of.
Exactly. Exactly. So then again, inside each of the catch block, I am writing this choice equal. Okay, no, not inside each of the catch block. So here, when the array index was out of bound, we exited the code, right? Here now, the two things that you can do. That's why I wanted to display both of these. Let's say path that you can take. First of all, you can terminate the program after handling the exception. You are saying you are giving the user some information that okay, this has happened somehow. I am sorry. I am terminating the program. So you terminated the program over here. The other thing that you can do is you can tell the user, okay, this has happened due to some issue. Now I am giving you another chance because this is kind of the user's problem. So I am giving the user another chance that enter some other value. So therefore, I am using that choice variable of do while loop, which I discussed earlier, right? So here is a small message. If choice would have been declared in the try block, then we couldn't have accessed it in the catch block. So as I already discussed this, so please keep that thing in mind. So since I'm using this choice variable inside the catch block, I have to define this choice variable outside the try block. So that's why if I go to the code, see choice was defined over here, which is outside the try block. Yeah, so here I'm taking the choice. If the user wants to continue, then he will, in the while loop, this y will be considered if he enters y. And then again I will come back over here in the try block, and then again I will ask the user to enter another new stride length. So then the user will know that I have entered 0 value. That's why the message it was given that you entered a 0 value, and it is now giving me another chance. So I can enter a new stride value, and then the program will work. So this is where these are the two different paths that you can take. Either you can use this kind of do while loop. Using a do while loop, you can allow the user to again apply for another iteration of the program, or sorry, another execution of the program using a new input. And before that, you told the user what is the trouble by writing the specific handler for that exception. And otherwise, if you want to terminate the program, that also you can do by using this kind of approach where you can terminate the program using exit function. So both are proper way of handling the exception in different, depending upon which situation you are encountering. Okay, this is the last catch block. As I already discussed, this is the widest class exception where you also don't know what is happening. So somehow you are not terminating the code, and also you are not telling the user to give another input, because either way we don't know what has happened. So therefore we are just printing the stack trace and keeping the program as it is. It will be terminated anyways. So yeah, that's what we are doing. So this is the exception E, last catch block. That's it. So we have kind of covered in this all the
Sir,
things that
can we catch system exit also?
exit is not any exception. Exit is basically terminate the program. Did you want to ask something different?
I think in Python we have this feature to catch.
Catch the exit. Exit. What I mean is exit is a function call where you are asking the program to terminate itself. Yeah. So basically we are catching exception. So if some exception or error occurs, that we can catch.
Yes, sir.
Yeah. So we have these two kind of situation displayed in this code. First is your problem as a programmer's problem. Second one is user's problem. In the user problem, we allowed the user to go for one more execution of the program using the do while loop. In the your problem, we kind of just printed the stack trace and then exited the program. But again, since programmer's problem is something which the programmer should correct before the code is actually given to the user. That's why ideally in any kind of runtime exception, you should not write try catch, you should rather correct your code. So I should have written here -1. For explanation, we kind of use the try catch. Okay, now we will come to the second type of exception, which is the user-defined exception. And this is now, since the basic thing we have covered, it will not take much time. What are user-defined exception, and in what kind of situation I might need user-defined exception? So mostly user-defined exceptions are required when you want to provide some features which are not considered either logical error or any, I mean, yeah, so it is not considered any. So what was logical error in the previous case? Divide by 0. Although it is a due to some logical mistake, you have encountered a divide by 0 situation, but divide by 0 is a situation which is well recognized as an erroneous situation, right? Array index out of bound is a situation which is well recognized as an erroneous situation. So no matter whatever logical mistake you did, but the result of that logical mistake is something which is widely accepted, conventionally accepted erroneous situation, right? But in some case, you might want in the program that this is against the business logic of my code. So you are writing the code in order to do some task, right? Now, maybe you want that this thing should not happen. So let me give you an example. So let's say you have a bank account and there is a minimum balance of 5,000 rupees set by the bank, right? Now, having an account balance of 5,000 rupees is not, I mean, having just let's say now the accounts are represented as a variable, right? You account balance variable. Account is an object, and in that object there is a data member called balance, integer balance, right? Now in that balance variable is an integer variable. Now you can have the integer variable storing value 5,000 or 4,000 or 2,000, whatever. That is not something well recognized inside Java, or basically conventionally not recognized as anything wrong. Integer variable, as long as it is storing any integral value, is fine. So if I store value 32 inside the balance variable, Java will not say it is an error or nothing will be shown. Like in that case, divide by 0, Java will show you arithmetic exception. In case array index out of bound, at the runtime, Java will show you exception array index out of bound. It will stop the program, right? The program will stop. It will print the stack trace. It will show that error has occurred. But here, if I have a variable in a banking application, if I have an account class and data and balance variable, and let us say the bank wants me, the bank wants the programmer to implement a feature of minimum balance of 5,000 rupees. That is not something that Java will recognize as a problematic situation, as an erroneous situation at runtime. So even if the account balance variable is 2 rupees or whatever 32 rupees, anything value which is less than 5,000, it will not give you any error at the runtime. So in that kind of situation, you want that if somehow at runtime due to some trouble, if the value of the balance variable goes below 5,000, then it should not allow that. It should give a error at runtime. What can be a very normal situation? That 5,000 minimum balance should be maintained. That constraint is there. Your account has 10,000 rupees and you have a withdraw and deposit function in the code that you have written. And at the runtime, the user is using the withdraw function and he is trying to withdraw a value of, let's say, 8,000 rupees. Now your account balance was 10,000. You are trying to withdraw 8,000. It is not allowed. But this thing is happening at runtime because the user will enter 8,000 value at runtime. That's the value he is trying to withdraw, right? So if he is entering 8,000, your program at runtime should be able to check 10,000 minus 8,000 equal to 2,000. So this 2,000 should be greater than 5,000, which is the minimum balance value. Is it greater than 5,000? No. So you should print a message to the user, minimum balance reached. The withdrawal is not allowed. This is what ideally your program should do, right? But how will you do that? Because all of this is happening after the user has entered the withdrawal amount, and that is there in the runtime, right? So therefore, in situations like this, you can use if else statement normally, but since we are handling it using exception, let us see how to deal with exception in this kind of scenario. So as you can understand, in this case, having a integer variable value below 5,000 is an error, is an erroneous situation, or which I want to be treated as an error. So therefore, I will make a custom exception class. I hope I could communicate the situation where you want to have a customized exception class. So here I want a class called negative exception. I have given the name, which is extending exception class. So this is the way to have a custom exception class. All you need to do is whatever name you give over here, that is fine. Some class ABC. As long as you extend the exception class, it will be treated as an exception. Basically one of the type of custom exception. So you write extends exception, that's it. Okay. Now, what is other than that? Here I have added an error value variable. It's not anything fancy. It doesn't make any sense at all also, but I just wanted to tell that it's like a normal class only. You can have data member and member functions over here. That's why I added an error value variable. It doesn't make any sense. Okay. So don't confuse, don't think about it a lot. There is just one variable. And then I have this, but this is important. Okay, this is very important. So this is compulsory in any exception class that you are defining. So you have to define the constructor. Okay, you cannot, I mean, it is better to define the constructor. Why? Because in your custom exception class, you have to mention the reason of exception, right, to the user or whoever will, in order to give the message. So here the constructor will have this string message as a parameter, and this index is basically because of this variable. If I delete this variable, I can remove this index. So as I said, you can ignore this variable. I mean, it's not something very fancy. So you can just keep this thing in mind. If I delete this int variable, error value variable, I can remove this int I also. It's not doing anything important. But this string variable is very important. So in case you define your customized exception class, keep in mind that you have to have this string message or string whatever variable which will contain the message of the reason why that exception is occurring. And after that, in the next line, you pass the message to the superclass, which is the exception classes constructor. So write super and then pass the message. So these things you know that whenever I have a no argument super call is there by default, but if I want to pass the parameter, I have to write the super and then pass the parameter to the superclasses constructor. So I'm just doing that. Again, the error value line is not necessary. You can remove that. So basically, super message line is important, and then negative exception string message is important. So any exception class that you create must have these things. Okay. Other than that, nothing is important. Everything is optional. I have also overridden the toString method to print a customized string for the exception object. Okay. That's also not compulsory. You can do it, you cannot do it, whatever you want. So after that, what we are doing, we have created a negative exception, a customized exception class. Okay. We have yet not discussed where, in which situation this negative exception class will be, let's say, it will be thrown, right? A negative exception will be thrown. Come to that a little later. Okay. So what are we doing what are we trying to do in this code? Basically, we are basically in the previous code we had a array of numbers which were representing sides of a triangle, square of sides of a triangle. Here also the same thing is there, square of sides of triangle. Only thing is now we have this linked list. Okay, linked list instead of an array. And we are initializing it using the same concept of square of sides, but from 1 to 30. So the length of the linked list will be 30 in this case. Concept is same, just using linked list, and the size is 30 in this example. And then same choice variable, everything else is same. Okay. Now here I am not asking the user to enter a stride value. Here I am asking the user to enter a max mint value. What is max and min value? So you see, the stride I will decide in a random fashion. User will enter the range of the stride. So user will enter a maximum value and a minimum value. And within that maximum and minimum value, I will decide what the stride is using a random function. Fine. So that's what this code will do. So user will enter max min. Okay. After that, what are we doing? Again, do while loop. And then we have started this try catch block. And here I have used a random hypotenuse squared method. So basically a method. Basically, I'm using a method. Rather than in the previous code, we were having all the work regarding the array was done inside the try block itself. But here we are using a function. Why we are using a function, that also it will be cleared a little later. So then inside this, I am passing the linked list, which is storing the sides of triangle, and the max and min value that I am taking from the user. Right? Okay. Because I have to select the stride on a random fashion within the max and minimum range, right? So that's why I'm passing it inside the random hypotenuse, this method. And let us go to the method. Public static void random hypotenuse, the linked list, and then the max min variable. After that, we have this throws runtime exception written over here. What is this? I will come to that a little later. Ignore that as of now. This is the same thing which I already discussed. Okay. Now I have this stride. So stride is also a list. We are creating the stride to also be a list, a linear list. Why? Because see, the max and min was the range which was entered by the user, and there will be multiple stride that I will take. Now, what do I mean by that? In the previous example, only one stride was there, and using that stride, we were iterating through the array, generating all the pairs of number that we want to sum up. In this case, I have a normal linked list like in the previous array, sides of triangle squared, normal just like the previous case. But here I will not generate or not ask the user for a stride, I will ask the user for a max min. Within that range, I will generate multiple strides using random. And corresponding to each of those strides, I will calculate the hypotenuse array. So there will be multiple hypotenuse arrays getting created, and each of those hypotenuse array will be corresponding to the randomly selected stride in each iteration. Okay, and since there will be multiple strides, therefore I am using the linked list in order to store the strides as well. Okay, so same thing basically I am doing multiple times, because in the previous one only one stride was used. Here I am randomly selecting multiple stride. Okay. Fine. So how will we write the code? Same, we have a for loop over here which is running from 1 to 10. Okay, and then we are generating a random stride value val1. As you can see, I'm adding stride.add val1. So that means what? 10 times this loop will run. So that means we are creating 10 stride values on random between the max and minimum range. So between the max and min range given by the user, we are taking 10 random values, which are basically 10 different strides, and they are stored in the stride linked list. After that, we are doing the same thing, which we were doing over there. Now here you see sides of triangle -1 I have already done. And then we are using stride.getI. So because it is inside the for loop again. So for each of the stride value, we are getting the stride and dividing it. Same thing, same line, right? The previous case it was just one stride. Here it is getI, because I have multiple strides, and in each iteration of the for loop, I will calculate the hypotenuse corresponding to that particular stride. So same thing again. After that, everything is same. Just same code. I'm not going through line by line. Exactly same code. Everything else is same. Only thing is, so therefore, what is the difference? The difference over here is I have already corrected my mistake. The logical error is corrected. Okay, fine. So then I'm directly going into the catch block after this. So before going into the catch blocks, again, what are the problems that might happen within this part of the code, with this try block? You can see the try block starts over here. First of all, the user inputs are there, because my mistake I have corrected. And that's what you should do. Unchecked exception should not be used for try catch. So here I have done that, but the user input issue is still there. So what we will do now, we will come back over here. Okay, and now let us see. We are so what do we want? I do not want the user to enter any value which is lesser than 1. Yeah, so which is lesser than 1, right? 0 or less than 0 is not allowed. So therefore, I am writing over here, class linear list extends linear linked list integer. So what I am trying to do over here? See, what was the stride value? The stride value was basically, So the stride was basically a number which should be greater than equal to 1, right? It should not be 0. Just a second. It should not be 0, correct? Okay. Now, when I'm selecting random numbers between two ranges, 0 can obviously come, negative numbers can also come. see if the user enters a negative value in the max and min. User is entering max and min in this program, right? So if user enters a negative or zero value in the max and minimum, then you can say that, okay, you should not enter any, I mean, that's user's fault. But let us say the user enters 0 and let's say 0 to be the minimum value and let's say 5 or 6 or whatever to be the maximum value. So the user might mean that, okay, 0 is the minimum range and 5, 6 is the maximum range. You select any number in between them. That is not very wrong from the user's perspective, because the user may think you will select numbers between that range. So, but from your perspective, it is wrong, because 0 should not be treated as a stride value. But when you are selecting randomly numbers between the range, you might select 0 as well, right? So therefore, in situations like this, you want to implement a feature. You want to basically say that in these cases, I will not consider it as a valid input. So how I will want to do that is come back to the original code when we are initializing stride. You can see over here, the stride linked list was created, right? And inside this linked list, we were writing stride.add val1. Val1 was generated by me using the random function call. So this might generate, the random function can generate any random number between this max to minimum range, right? So in case it generates a number which is not valid, which is basically 0 or negative, I won't know that, because that is happening randomly at runtime. And then I'm adding the value inside the stride. So therefore, while adding the value inside the stride, I will put a condition inside the add method that if the value that I'm trying to put inside the stride is 0 or less than 0, then you do not put it inside the stride, or whatever. Then you take care of it, whatever. Basically, I will come to that, but basically you want to tell that, or you want to do something else. You don't want that value to be present inside the stride linked list, right? So you want a feature provided by the linked list stride over here, where the add function will see that if the value that I'm going to add, if the parameter that is given to me in the add, that is given to me, which is val1 in this case, if the add method will see this, add method will see if the value that has been supplied to me, if that value is invalid, then I will not let that value to be added inside the stride linked list. That's kind of the feature that I want to have. So how to have this feature? Because add is a method of a linked list class. How can I modify the feature of linked list class? See, this is very interesting, because this is not only about exception. This is also about how you can modify the different methods, add, get, set, all this method of the collections framework, which you have learned in the previous week, by overriding them, right? You don't want to override all the features. You just want to, so linked list has multiple functions, right? Add last, add front, remove, pop last, or I think remove last or remove front, whatever, add, remove, thousands of methods. I just want to modify a specific method depending upon my need. So how will I do that? See that thing that we have done. I am creating my own linked list class, which I named as linear list, extending linked list integer, normal integer linked list. So this is the linked list collection, right? Whenever you define a normal linked list of integer type, how you define linked list, angular bracket open integer, L list equal to new linked list. That's how you declare, right? So that linked list integer I have extended, the linked list integer class. You see, once I extend it, all the features of linked list is there inside my linear list class due to inheritance. Now I override only the add method. Only thing is I have to take care of the signature of the add method. That should be same as the same add method according to the linked list class. And what I do over here is I set a condition. If I is greater than less than equal to 0, then you throw new negative exception. So this is the exception which I customly created over here. Class negative exception extends exception. So you throw the new negative exception. So why I have written this throw keyword? That is something new. So this throw keyword is used to throw an exception. I mean a user defined exception customly. So till now exception has only occurred where the program ran into a situation which is conventionally accepted as a problematic situation. That's what I told a little bit earlier. And that's why the exception was already occurring. But since this is not a situation which is considered as exception or erroneous automatically by your program or by conventionally, it is something which is against your business logic or your, I mean, idea of how the program should behave. That's why you also have to tell the code when I want the exception to be thrown, right? Because that's not a situation inherently known to the system. So therefore, you tell if this is the situation, if I is less than 0, then you throw the new negative exception, which is my custom exception. So throw keyword is used to throw the exception in a, whenever you want to throw an exception, you write the throw keyword, right? Okay. And as I said, you also have to put the message. So this is the message of that, this negative message, right? So as I told, this is compulsory. So here you mention the message that why this is happening, and you have given negative value given. Negative or 0 value, but let us, I'm not modifying it, let us say negative value or 0 value given. Okay. This I, you can delete it. I'm not doing anything good. So anyways. And but the thing is, if I'm overriding the add method, you see that then I have to implement the whole add method. But I don't want to implement the whole add method. I just want this feature that whenever I'm adding anything in the add method, right? When I'm using the add method to put anything in the linked list, I just want this feature to be checked, right? I just want an exception to be thrown whenever the value is less than equal to 1, less than equal to 0, right? Then I want this exception to be thrown. That's all I want. I don't want to write the code of add method by modifying linked list, whatever way the add method works. I don't want to write that part of the code. So what I will do now, I will just return, because add method returns a value. While before the return, I mean, in the return statement, I'm just writing super.addI. In case this would not have been a method which returns value, I will not write the return statement. I will just directly, after doing what I want to do, what I want the additional features of the add method, which is basically this new negative exception throwing feature. After that, I will call the super.add and pass all the necessary argument to the super.add method. So what this will ensure that all things done by normal add method of linked list will be anyway done, because I am passing the parameter to the original add method. Just before calling the original add method to add the value in the linked list, I'm modifying this extra, I'm adding this extra feature of throwing the negative exception which I created in case the value is less than equal to 0. So I want to again just mention this thing. You see, don't just see the exception part, that is obviously our discussion, but also see how we are modifying a method predefined in a linked list in a collection class. According to our need, we are just adding something new, and then we are using the original description of the method, and then this will just serve as a normal, and then after this you can use this as a normal add method of the linked list, right? Only with an additional feature. So you can do stuff like this wherever you need in order to customize different features provided to you already by some collection type. So yeah, please take note of these kind of small tricks that you can do. Okay, so now this will basically work as an add method which filters out any number less than equal to 0. Right? So what will happen when I enter anything wrong, anything 0 less than equal to 0, an exception will be thrown. So as I told, throw is the keyword to throw that. Okay, so now another keyword which is there, which I have not discussed, and in the previous code also I have not discussed, which is the throws keyword. So this is throws with an S, and this is just throw. So what is this throws keyword? Now please be attentive now. So as I said, there are two types of exception, unchecked and checked exception. Checked exception is called checked because the compiler checks for the occurrence of these kind of exception. And unchecked exception are not checked by the compiler, or let us say the unchecked exceptions occurrence is not checked by the compiler. Now this thing which I told earlier, we will see the meaning of that. Please be aware what I just said, that please note what I'm telling. Compiler checks the occurrence of checked exception. Occurrence term is highlighted. Okay, occurrence is the main term. compiler checks the occurrence of checked exceptions. It does not check the reason of the, why it is occurring, when it is nothing. It will not check the reason of its occurrence. Like in the divide by 0, the reason was it is getting divided by 0. Right? That is, so here what is the reason? Compiler will not check. Compiler will just check whether is there any checked exception. Checked exception are basically user defined exception. So compiler will check, is there any user defined exception in the code? If there is a user defined exception thrown inside the code, there are two things that you must do. Not two things, basically either or. So either two things, one of them you have to do. Okay. So again, I am mentioning, if a part of your code throws a checked exception or throws a user defined exception, same thing. In that situation, you must do either of the two things. Right? What are the two things? If you are writing a try catch block, that means that first is write a try catch block. So if I write a try catch block over here and put the whole if statement, which basically consists of this throw statement as well, inside a try catch block, then I can remove this throws negative exception from here, because I know that the whatever exception I'm throwing at this point, that is being handled by the try catch block. Okay, compiler will know that, because this throw negative exception is a new exception, custom exception which you have created. So since this is something which you have created, you must handle it also. Right? This is not a situation well known to, conventionally not treated as an erroneous situation. That's why if checked exception are user defined exceptions, therefore if you have created the exception, you must also handle it. That is the philosophy behind checked exception. And therefore compiler will check the occurrence of this checked exception. So if there is somewhere you have written a checked exception, and when I say written, what do I mean by that? Somewhere you have written a code which consists of throw, then a checked exception. That basically you are throwing a checked exception. In that situation, compiler will make sure two things, and then only it will allow you to run the code. And that two things is, it will check whether you have written that inside a try catch block. If that is there, fine, it will allow you to run the code. Or it will check whether you have mentioned the throws clause in that particular scope of the function. So if you write throws clause in the function definition, function declaration, right? Using the throws clause, you mention the name of the exception that function is throwing. This tells the compiler that, okay, you will go and see that whether I am throwing any custom exception or not. That's what the compiler does. So compiler will come and see you are throwing a custom exception, and you have also not written try catch block. So compiler will not allow you to go to the runtime, right? So then if you write this throws keyword, then it means compiler, you are telling the compiler that I am not handling the exception at this point inside this method, right? Inside this add method. And that's why I have not written the try catch block inside this add method, because I do not want to handle the exception at this point. But you do not worry. You let me go to the runtime. You let me execute the code. Do not show a compilation error. Okay? Because I promise you I will handle it later on, where the add method will be called, or basically where, this method which consists of my throw keyword, right? Wherever I'm throwing the custom exception, whichever method, basically in whichever method we are doing that, I promise you that I will handle the exception when I am calling that method, or from wherever I am calling that method. So inside main method, if I call the add method, I promise you that I will put the main method's that part inside a try catch block. So I will call the add method only inside a try catch block. So this promise that you are doing is conveyed to the compiler in the form of this statement, throws negative exception. So as I said, in order to handle an exception, there are two ways. Either you can handle it at that very point. So in order to do that, you write a try catch block over here. Otherwise, you can mention throws and then mention the name of the exception. This will also tell the compiler that, okay, I have not written the try catch block over here, but I will write the try catch block where I am calling this method. And there you have to put the try catch block. If you do not put it there, then again compiler will not allow you to go to the runtime. Okay, so this is the difference between throws keyword and the throw keyword. Throws keyword is just telling the compiler, ignore that I have not written try catch block in this scope and still I am throwing a custom exception. So ignore this step, because I promise you I will handle the exception. I will write a try catch block where I am calling this particular method. Right? Okay. So that is the meaning of throws keyword and throw keyword. And accordingly, you can see when I am calling the add method, I must have written it inside a try catch block. Is that? Yeah, you see the strike.add, it's there inside the try block, right? Okay. So fine. So these are throws and throw keyword. Now coming back to our this main method, this function, everything is same as the previous code only, there's nothing different, right? And we have this user defined exception which will work very properly.
Excuse me, sir.
Yeah.
Sir, can you scroll up a bit?
Top to the top, okay.
Yes, sir, the 64th line. So this int value 1 is equal to min. Why are we adding min?
64 int value 1 equal. Okay, why are we adding minimum?
Yes, sir.
Let me just check. This is a random number between this range. Okay. Okay, so this is basically a stride value, right? Some stride value, and think if the user enters a negative number, then that will be added. I also don't remember why I wrote this min plus. Let me just think for 1 second. If I have a number, any number between max and min, that is a stride. Okay. I'm adding that to the stride. It's fine. Might go out of range. Okay, so this is just, you see that normally whenever we are writing any number, whenever we are trying the random function to create numbers between two ranges, I have to add the, so what will this create? See, what will this next int, random dot next int max minus min plus 1, what will this value generate? It is still the number between max and minimum, but I am giving you the reason. What is max minus min? Max minus min will be the difference, right? When I write difference plus 1, that is basically, I mean, just plus 1 is done because I want to have the last value as well. So that's why plus 1. So this basically is the difference value between max and min. Now, if I want values to be generated between two given ranges, so I have to do what? I have to take the minimum value and then add the difference, which is getting generated. So the random is done on the difference. Observe this. So max minus min plus 1, and then I am doing random. So this means whatever is the max minus min plus 1, that value will be whatever basically is the difference. Ignore the plus 1. Okay, plus 1 is done just because of the boundary case. So here, consider this whole thing as the difference. Consider this whole thing as the difference. So let us take an example. It will be clear with an example. So let us take maximum is 10, minimum is 4. Right? Maximum is 10, minimum is 4. So forget about this max minus min plus 1. Just consider the whole highlighted part is the difference between the two numbers. So what will be the difference between 10 and 4? 6, right? 6 is basically the difference between these two numbers. Now I am applying random on 6, right? Random is applied on 6. So if I say randomize till the value 6, that means 0, 1, 2, 3, 4, 5, or 6. These are the values that might be generated, right? 0, 1, 2, 3, 4, 5, 6. So if I want, but is that the range that, or let us say the idea was generate number between 10 and 4. But what am I generating? 0, 1, 2, 3, 4, 5, 6. That is not between the range, right? So if I want that to happen, that you generate the number between this range, then I have to add the minimum or the starting, right? Because the difference plus the minimum will generate the value between the two ranges. Normally, it's like normal. You think about it normally. It's normally we are doing that.
Okay, sir.
If you
Understood.
are still confused, just take two numbers. You will understand. Unless and until you add the minimum value, and then you are generating a difference. Now the difference is a random difference. I mean, not difference. Basically, you are generating a number which is random up to the difference. Now, if you generate 2, so you add minimum plus 2, so that is one number. Then again you generate 3, which is also less than difference. So then you add minimum number plus minimum value plus 3. So this will generate different random numbers. But since the difference is 6, all the random number will be lesser than 6, and therefore when you add a minimum plus one of the random number, that value will always be lesser than the maximum value, because only when the difference is the max 6 value, then only you add minimum plus 6, it will go to the maximum value, which is 4 plus 6 equal to 10. Other than that, all the cases when I generate any random number which is lesser than 6, that is basically which is lesser than the difference, and I add the least number with it, it will always generate a number which is between least number and the maximum number. Why between least and maximum? Because anyway I am adding the least number, minimum. So this term, minimum plus xyz, whatever I add, that will be greater than minimum, because xyz is guaranteed to be a positive number. So therefore, whatever I add with minimum, as long as the result of random is a positive number, this whole thing will be greater than minimum. So that guarantees the lower bound. Now the upper bound is guaranteed because I am only generating random number between the difference value of the ultimate of the extremities of the minimum and maximum. So that guarantees whenever I am adding that difference value, randomly generated difference value between with the minimum variable, it will always generate a value which is lesser than the maximum variable. Okay, so that's the logic we are adding minimum.
Okay, sir.
So anyways, so now coming to the exception part. Again, here also the arithmetic exception can occur, right? Because user input, he can give a range -1, -3, whatever, the same thing. Okay, and the stride value that, I mean, you can see over here the arithmetic exception, the last value of stride must have been 0. Okay, acha, please provide stride non-zero. Okay, so let us change the code. I think in the here I added this equal to 0. So I want this to be less than 0 only. Okay, so that will generate a arithmetic exception anyways. So I modified that. I thought that, okay, let us add all the faults in one exception, but in this code I kind of, when I wrote this code, I decided to have the arithmetic exception as well. So if you wrote equal to 0 over there, which I just deleted, if you would have written that, then you could have deleted this catch block. But let us still take the 0. So since basically this exceptions add method is only considering I less than 0, if the user enters or if the random function generates a value which is 0, then the stride will still be 0 and divide by 0 exception will still occur. And basically that means arithmetic exception will still occur. So therefore arithmetic exception. And same thing, I'm just doing the same printing. Other than that, runtime exception. So this part is same. I'm not going through that again. This is the new thing. So I have defined the new customized negative exception, which will occur when the value is less than 0, which is particularly happening when the value is -1, -2, something like that. And why that is happening? Because the user has entered the minimum range to be in the negative domain, right? Because only in that case the random number will generate a negative number, because the minimum value entered by the user is a negative number. Only in that situation our random function will generate a negative number, right? So that is happening. And obviously if that is the case, if the random function over here if the random function over here is generating a negative value in val1, so that means our maximum and minimum was basically sure to be in the negative domain. So then if the add method is adding a value which is negative, we have already defined in the add methods by overriding over here, right? If I is less than 0, you throw the negative exception. So obviously you can understand in the situation when the negative number is there, this add method over here at line number 66 will throw a negative exception. The custom exception which we have created will be thrown at line number 66 in case of negative number, and therefore this catch block will handle it, right? And see what we are doing. Get message function we have anyway discussed. This get message will basically print the message which you have given while declaring the negative exception class, right? Please enter negative number. You have entered negative number or something like that I wrote, right? Yeah, negative value given. So this message will be printed by your get message function, right? Okay. Yeah. Okay. So then this is a new concept, and this is the last concept regarding exception. After that, our exception topic will be finished. So what were we doing in this line? So we could have terminated the code over here only. That you have entered a negative output, or by using the get message anyway, that message will be printed that the value is negative, and you could have written the system.exit, or you could have told the user that using the get message over here, you have already printed that negative value is there. So do you want to continue? If yes, same thing like we discussed. So that also is there. You can allow the user to go for one more new execution. So either way. But here we are learning a new concept. Okay, so what is this? This is called chaining of exception, right? Chaining. So what is chaining of exception? See, this is not very understandable in this situation, but in a big software where you have written a very big software which has thousands of different modules and different .java files, right? You have, let's say, you have written such an application which has, let's say, 5,000 .java files, different modules written by different people, which is doing different tasks, intercommunicating between them, right? Multiple things. So if you are doing stuff like that, then it might happen that at some point in some .java file, an exception might have occurred, and maybe that feature you are also using indirectly in your .java file. Now all this .java file comprises the whole software, but you are writing one .java file and some other guy is writing another .java file, and somehow you are using the feature he has implemented in his code, right? And you are using it as just a function call because you want the utility provided by that feature, by that function, sorry, right? But there is an exception occurring in his code, right? In his function definition, there is some problem, and due to which an exception has occurred. Now you see, what will happen is that exception will be propagated, if not handled. That exception will be propagated down the line, it will be propagated down all the intermediate steps, intermediate modules, multiple .java files and everything, right? All the function which are getting called in order to call that function which you are trying to use, right? It might so happen like our fun1, fun2, fun3 example. Fun3 was called by fun2, fun2 was called by fun1, fun1 was called by main method. So you can have a hierarchical function call sequence like this, right? So if an exception occurs in one area within this sequence anywhere, it will be carried down the line if not handled at any point. So for you, who is basically using the utility of that method, of that function, it might so happen that you have no idea what that exception means, right? Because you have not written the code for that part, right? Some other guy has written it. There may be thousands of intermediate people who have written their own parts, and then again that guy has written depending upon the guy previous to him has written, right? So when you, let's say 10, 12 level down, you have no idea what that code is doing and what that exception means. So even though that exception is coming to you because you are using some feature of a code written by that guy, but the exception will come to you and it will be shown that due to this the program stopped working. It got terminated. Now you don't know anything about it. How will you correct it? You cannot understand why that happened. Right? That's the first point. Even if you know, if somehow you know that this is not my fault, then at least you can tell that, okay, that guy, that you have done something wrong, correct it. But unless and until you know that, how will you understand where the thing is getting wrong? Right? So in those kind of big softwares, something we can use, some good practice that we can use is called this exception chaining. So what is this exception chaining? So here what we do is we create a custom exception class and we say that with that custom exception class, we will have in the constructor a properly well-defined message. Now that message will be such that it will be understandable by anyone. I mean, any programmer who might be 10-15 levels down, who is using your method. But at least even if we send a message to that program as well, they will understand somehow that something, some problem is happening at this level and because of this situation. So this is just a wrapper class that you are creating, or wrapper means a wrapper, not wrapper class, because in Java wrapper class is something else. But let us say it's kind of a wrapper that you are creating around the real exception which has occurred, and you are giving the name to that wrapper exception class, and adding some messages with that wrapper exception class, so that then you propagate that wrapper class, that wrapper exception class. Okay, so when that wrapper exception class is getting propagated 10-15 levels down the hierarchy, the person who is reading that exception message, they will still understand something is some problem has happened in this part, right? So therefore, in situations like that, you do this kind of thing, which we call exception chaining, where we basically chain one exception, which is more easy to understand by some other people. The messages easy to understand the messages by some other people. We chain that from an exception which is very difficult to understand, whose messages are very difficult to understand, because only the people who are working in that domain, they will understand those messages and they will be able to debug the problem. But someone who is using it from a, let's say, much later in the hierarchy, they will not understand. So in order to make them understand where something might have gone wrong, we are basically adding a wrapper exception class around the original exception class by adding detailed messages and easy to understand messages, right? So that's what we call this. That's why we do this chaining of exception. And how to do that? Basically, I'm creating a new exception class here, and I'm giving the name negative array size exception. Okay, because if so first of all, if the negative array exception, what was negative array exception? Because of which we modified the add method. That was whenever the value of the stride which we are trying to enter into the stride linked list is negative, it should be a negative exception should be generated. Now you see, because of the negative exception, or because of the negative value being added inside the stride, the iteration value will also change, because the stride is negative now. So if the iteration value will also get negative. Why? Because see this, it is divided by stride, right? So if stride is negative, then this iteration will also get negative, right? So therefore the array size, the hypotenuse array size will also get negative. So therefore negative array size exception will be thrown because of the negative size of the array. Okay, so therefore I've created this negative array size exception class, okay, and created a new exception object, and then I am telling new exception dot init cause. Init cause means initialize cause. So I'm initializing the cause of new exception, which is a negative array exception. I'm initializing the cause of negative array size exception to be the E exception, which is negative exception. So the cause of occurrence of negative array size exception is E, right? I'm initializing the cause is E, which is negative exception. So the cause of occurrence of negative array size exception is negative exception. And that is true, right? Because the negative exception occurred because of negative stride length. Because of negative stride length, the iteration variable was negative. Because of iteration variable being negative, the array created using iteration variable became negative. So therefore, I'm getting the array size exception. Okay. So therefore, the cause of negative array size exception is the negative exception. So in order to initialize this, in order to implement this, we use the init cause. I initialize the cause of this new exception to be E, which is negative exception. This is called init cause function. This is used for chaining exception. So that is a new concept. And then what
Sir,
I'm doing is, yeah.
inside the negative exception class, we have defined a toString method with a message.
A negative exception class, we have overridden the toString method. So what happened? Yeah. That is
There
not
is
compulsory.
So there is
Huh?
also this super, and we are using the message as parameter. It is also going to override toString method inside the exception class.
Sorry, what? I didn't get it. What?
Sir, the constructor for negative exception, we are passing a parameter called message, and we are using the super method. So that is also overriding the toString method.
No, that is something different, right? ToString is when I print the object directly. That's where ToString starts into
So
action.
that is for get message method.
That is for get message, correct?
So in this case, sir, when we are like passing the E as a parameter for init cause, which one is getting passed as a message?
This is the whole, not message. This is the whole object's property, right? So if I have an exception, negative exception object, right? So that negative exception object, this message will be printed if I write that object dot get message, and this message will be printed if I write system.out.println obj. Obj is the object of negative exception. So that is the idea. Now, when I'm writing init cause, I'm not adding a message. I'm adding the object itself inside init cause. See, init cause E. What is E? E is not a message that which message will be added, whether it will be the message for toString or whether it will be the message for, the message in the constructor. No, we are not adding any messages at all. We are adding the object. I am telling you the negative array size exceptions initialized cause is, or the reason for the occurrence of negative array size exception is negative exception. So I am adding the whole negative exception object as the cause. Right now, if you write,
so sir, for the new exception if we get the cause, we are getting the E as cause.
Yeah, if you write the get cause method that we will see in the main method, if you write the get cause, then you will get the E object, and then with the E object, if you write new exception dot get cause, init cause is initializing cause, just the contrary, get cause is also there, which will give you the object. So if you write get cause in new exception dot get cause, not here it is initializing the cause, right? So later on when the exception is thrown, right, and you write the get cause method, so that get cause will return you this variable, basically an object of this class, and then using that you can do whatever you want. You're getting the object.
Yes, sir, understood.
Okay, so then I'm throwing it, because since anyway my whole idea of creating a new exception or doing exception chaining is basically documentation purpose. So I'm making it a understandable exception with messages and all, right? And but then once I have done that, I have to throw it, right? I have to throw it down the line so that whoever who was supposed to get the negative exception gets my new exception, and by reading this new exception, they will at least be able to make some sense where the trouble has come from. So in order to do that, I must have to pass it, because now till this point we have caught the exception, right? Initialize cause, caught the exception. After that, you have to throw the new exception which I have stored. So therefore, I'm throwing the new exception. So keep this thing in mind. After init cause, most of the time we throw the exception. Okay. Now coming to the catch methods. Catch to the coming to the main part. Yeah, so here I have called the random hypotenuse sequence function, squared function. Right? normal println choice, everything says. So here, see, I have handled the negative array size exception. Keep this thing in mind. I have not written negative exception. I have written negative array size exception, which is the exception that I created, right? So there I am writing system.println e. This is the negative array size exception itself. Here I have written c e.getCalls. So e is basically the negative array size exception. When I write e.getCalls, it returns the negative exception object. Now using that negative exception object, I can again call other methods of negative exception and do whatever I want to do. And at the end, I'm writing exception e like normal. So you see, therefore, this is called exception chaining, and why we do that, that also I explained. Right? Everything else is quite same, nothing different. Yeah. So that was exception. Any doubt you guys have? So exception I have finished in all the topics are discussed. Now the next important topic is package. Other than package, logging is something that mostly we will not do in that much detail. It will not be that important as well. Assertion is anyway a very small topic. So the main big topic is exception and package in this week. Exception we have cleared in this discussion. Package, again, it is smaller than exception, obviously, but again, it has some rules that you have to keep in mind. So regarding package, we will discuss it in the next session, right? Yeah. In exception, anywhere if you guys have doubt, please ask.
Will that be tomorrow? Will you be discussing it tomorrow about package?
Saturday's session, right? Saturday's session.
Yes.
Package discussion will be done for sure. Whether I will do or Kubra will take, that is yet not sure. But package will be done.
Sir, why don't you try to be there tomorrow?
Okay, let us see. Let us see. I cannot promise, but hopefully I will try.
Sir, one more thing.
Huh.
Sir, if you had to summarize the difference between code 6 and code 7, the key learning points, can you summarize it, like, if it's possible?
Code 7 is primarily checked exception, where I am declaring an exception of my requirement, which is not a conventionally accepted exception, and that is why it will not occur automatically. Divide by 0 is a condition which is happening automatically, and therefore automatically at runtime exception will be thrown. Arithmetic exception will be thrown whenever you are having a number and using that number with to divide, and if that number is 0, then automatically an exception will be thrown, which is arithmetic exception. But here nothing will be thrown automatically, because a stride value is an integer linked list, and that integer linked list can have negative number.
You mean in code 6 we couldn't have an arithmetic exception?
No. In code 6, arithmetic exception can happen automatically, because this stride can be 0, right? So if the stride is 0, divide by 0 can happen automatically, right? And whenever divide by 0 is happening, an exception will be thrown. That was arithmetic exception. But here also I have arithmetic exception. That's not the point. You said what is the primary difference? So the difference is not arithmetic exception part. Arithmetic exception part is same in both cases, because both of them will be divided by 0 exception. What I'm trying to say is all the exceptions which are automatically, which throws an exception automatically, right? So divide by 0, whenever something is getting divided by 0, an exception will be thrown, because Java knows that it is getting divided by 0, and therefore Java automatically throws an exception, right? So that is what we call runtime exception, which will happen automatically. Or sorry, not runtime exception, basically what we call unchecked exception, right? Now in some situation, array index out of bound, that is a already known situation which is considered as an exception, an erroneous situation. So automatically an exception will be thrown in all those cases, right? Whenever, what I mean to say, at runtime, automatically if that thing happens, exception will be thrown. But if I have a stride value, let us take in this example, let us take instead of I greater than 0, let us consider here as I 2 as well. I must be if I is less than 2. Now even 1 is not considered as a valid value, or let's say if I write 4, 1, 2, 3 is not considered as a valid value. So see, no matter what happens at the runtime, if I have the stride value as 1, 2, 3, anything, right? And divide it by, so what will happen? So here when I divide by stride, 1 to 3 division is proper division. This is not something which Java will know automatically. This is an exceptional situation. Also having 1 to 3, since I have written this -1, array index out of bound will not happen, right? So the point is, this situation, when I am basically, if I want the value to be less than 4 in this case, right? This situation will not be automatically throwing an exception at runtime. This is something I want to be considered as an exceptional situation, but it will not happen automatically, like divide by 0 or negative array size, stuff like that. So in order for this to be treated as an exceptional situation, I have to define a separate exception class. And that's what we call user defined exception, right? Which we have defined over here, negative exception. Okay. And then I am just mentioning and then since this will not automatically be thrown, I also have to throw the exception and mention the point or the reason when that exception will be thrown. So that's what I'm doing over here. That if the value of I is less than 4, so then you throw the negative exception. And I'm doing that inside, I'm doing it in this code inside add method in a linked list, but that's not the fundamental point. The fundamental point between these two code is, in code 6, the exception was occurring because of a condition which is well recognized and automatically considered as an erroneous situation. And because of that, an exception was getting thrown automatically by the system, which is divide by 0, negative array size, stuff like that. But here in this example, if I want a specific feature, and that feature is nothing but I want that any value of I should be, or basically the value of stride should be less than 4. Now, greater than equal to 4. So in this kind of situation, obviously having a stride which is, let's say, equal to 2 or 3, that will neither result in divide by 0, nor it will result in negative array size, because I have corrected the code by subtracting 1, nor it will result in any kind of situation which will be automatically considered or known to Java as an erroneous situation. But I want the value to be greater than 4 according to the business logic of my code, basically according to the requirements of my code. So if I want to have this customized erroneous state, okay, so that is I think good term to describe this, customized erroneous state. And I want the Java program to know this customized erroneous state and always treat this erroneous state as an error whenever this state is reached, whenever this condition is fulfilled. I want Java to consider that as an error as well. Just like it considers divide by 0, negative array size, and already accepted stuffs like this as erroneous state, I want Java to consider this also as an erroneous state. So that's the point where we have to declare our own exception, customized exception. And these exceptions are what we calling user defined exception or checked exception. Now, one important point I forgot telling, that why I told you the reason for checked exception, that compiler will see that whether you have mentioned the throws clause or not. If you have not mentioned the throws clause, then it will, so if you have not mentioned the throws clause, then what will happen is compiler will give you a compilation error, because it will see that you are throwing a customized exception, but you are not promising me that you will handle it later on. Also, you are not writing this throw keyword inside try catch block, because this is an exception. Exception should be handled. So either you write try catch block, which tells the compiler that you are handling it, or you at least mention the throws clause on that function, which will tell the compiler I'm not handling it now, but I will handle it later on. Okay. So that is the reason the throws clause is used. So if you see I remove this, it will show compilation error. You see this red line came over here. And if you go over here, see unhandled exception type negative exception. So it is not handled. If I put a try catch block, then it will say, okay, it's fine. I have no problem. Anyway, so just.
Sir, can a class throw exception?
Huh?
Can a class throw exception?
Class means inside class only you will write code, right? A class has what? A data member and a member function. An exception cannot be a data member, right? You can have an exception object as a data member, but I don't know in what kind of situation that might be useful. Getting the point? Class means what? You cannot write, I mean, if you write a normal code inside class, that means what? It should either be a data member or you should put it inside a member function of the class. So this is just a member function of the class itself, add method. But if you want to say that whether I can write exception over here, I mean, in the open region over here, so that means you are creating an exception as a data member of the class. Now, I cannot think of any practical situation where you might need a thing like that. But yeah, if you want to use it as a data member, you can write it. Anyway, so if I write exception over here, you see all the errors go away. Because now the compiler knows that you have handled the exception. So you are throwing an exception over here and you have handled it in the try catch block. But if you remove this catch block or even the try block, then it will say, the compiler will say that I don't know what is happening and why you have written this exception called throw, right? But I see that you have not handled it anywhere. So you must have the responsibility of handling it when you have defined it yourself. So then either you put a try catch block, as I already told you, or over here you mentioned the throws keyword, which makes a contract with the compiler that I am not handling it now, but I will handle it later on. Okay. And later on, if you do not write it the try catch block where you are calling the add method. So later on means what? Whenever you are calling the add method at whatever method in the code, wherever you are calling the add method, you must write a try catch block, and within that you call the add method. Right? You can see over here, as I already discussed once. See, the add method is called over here, which is obviously there inside this try catch block. So this throws keyword is a promise to the compiler that I'm not handling it now, but I will handle it later on. Okay. So what I will write over here, first of all, I can write the name of the exception itself, which is negative exception, or I can also write any superclass exception. So I can write, let's say, that also is fine. Okay. But for the time being, let me complete it. So this is the reason. So I want this specific feature of value I less than 4, which is not causing any normally accepted erroneous situation. But I want this to be treated as an erroneous state by the program. So in that kind of situation, we are defining a customized exception class, custom exception, which are basically what we call checked exception, right? So you see, this is why we call checked, because unless and until I mention this throws keyword or I write try catch, compiler will not allow me to proceed. Compiler is checking that if you are throwing this newly defined exception, you must handle it. So this check is done by the compiler. Compiler is not checking the reason of the exception. Compiler is just checking if you are using throw keyword. That means you have created a new exception of your own customized exception, right? Because otherwise you don't need the throw keyword, because compiler, the Java system will automatically throw exception depending upon some erroneous situation which might happen at the runtime, right? In the code 6, divide by 0 and stuff like that, negative array, things like that. But if you are writing throw, that means you are forcefully creating a customized erroneous situation and telling the program to consider this as an erroneous state. So if you are doing that, then you must also tell the program that how to consider and how to handle that erroneous state, right? And if you do that inside try catch block, that is fine. If you do not do that, at least tell me that you are promising me to do that later on when you are calling the method add. So that promise is basically this throws negative exception. Okay, and then you keep your promise. Just a second, and then you keep your promise by writing the try catch block whenever you are calling the add method. Okay, that is one thing. Now, if that is the reason we call this customized exception or user-defined exception as checked exception, does that mean if instead of negative exception, I would have thrown an unchecked exception, which is called unchecked exception, right? Like runtime exception, like array index out of bound exception, like all these arithmetic exception, which are all considered as unchecked exception. So if that is the case, if I would have forcefully thrown an unchecked exception, does that mean that compiler will not give me error even if I have not used throws keyword? Let us see that. I hope you got the point, right? What I'm trying to do. Checked and unchecked exception are two types. Checked are this custom exception, and we saw that if I remove these throws, it is showing me error, because this compiler is checking that this is a custom exception that you have created, so you must tell me the way to handle it. So if I am not telling you the way to handle it, at least tell me that you are writing throws and promising me to handle it later on. If you are not doing that, also compiler is basically showing you error. But in case of unchecked exception, I told these exceptions are not checked by the compiler. So according to that logic, if I use an unchecked exception name over here and delete these throws as well, and do not put try catch over here as well, then compiler should not tell me or should not stop me. Still, it should not stop me, because these are unchecked, because compiler does not check them. That's what the idea is. So if I remove this, it is showing error. But instead of this line, if I write any unchecked exception, so let us stick with you can write runtime exception, you can write arithmetic exception, you can write any unchecked exception. So let us write arithmetic exception. See, no error. I have already deleted throws. I have not used try catch. Still, it is no error. Compilation is not stopped, or compiler is not showing you any error. So this is the reason we call all these exception as unchecked exception. Okay. Yeah. Go ahead. You are asking something.
Yes, sir. Earlier I was asking the thing that inside that Boolean add function, you are writing the throws keyword and then the exception type. So can't we just do that for the class header, like class linear list extends linked list and then throws?
No, because I can have other methods as well, na? Inside the class I can have another public whatever, some other method, some other 4 or 5 methods. Now class throwing an exception does not make any sense, because exception is thrown at a specific point. So it might so happen that this function is throwing exception, but the other 4 function is not throwing exception. So if I write exception throws in case of class, that does not tell the compiler that in which function the exception is getting or generated, or where or how to handle that exception, because other methods are not throwing you exception. So that's why, and other methods are also the property of class. So if you are considering class being throwing an exception, then that is not a correct thing to do, because the other methods are not generating any exception.
Okay, sir, understood.
Okay, so as I think
it is just a strictly compilation error that will show.
Exactly. Okay, so the primary difference between code 6 and code 7 is code 6 deals with already accepted erroneous states, which are mostly called unchecked exception, and we don't need to write try catch block for them, but in our example we did in order to discuss the concepts. Code 7 primarily discusses situations where the state is not at all erroneous, and that's why automatically no exception will be thrown. But I want, according to the requirement of my code, some situation or some states of the code to be treated as errors or erroneous situation. So therefore, I am defining a customized exception class. Okay, and then I am telling how to handle them, handle the situation by using try catch block or using throws or whatever, right? But this is more about a feature, according to the requirement of my code. So this is customized exception, and that was inherently a or let's say implicitly considered exceptions. That's the primary difference between these two things. There are some other topics that we discuss like exception chaining and stuff like that. That is different. But yeah, primarily these are the two things which are different from port 6 and port 7. Yeah, that's it, I think. So we will stop the session here, and packages will be done tomorrow. Yeah, I hope it's okay, right? We can stop it. Good night, everyone. Then.
Yes, sir. Thank you. Good night.
Stop.
Thank you, sir.
Thank you.
Thank you, sir. Good night.
Thank you, sir.
Thank you.